Hello?
Yeah, it's
Okay.
working. Yeah. So now you can clip it.
Okay, I'll turn this off.
A little close to your mouth.
Okay. Does it work? Yeah, I think it does.
Yeah, this works. Yeah. hope I pronounced that right. Yes? Okay. Who is the Database Solutions Architect at AWS, and Wanda, who is the Principal RD of Postgres Solutions. And take it away.
Thank you.
Is that better? Yes. Okay. So this session is for folks with an Oracle background who are looking to migrate from Oracle to Postgres, or just anyone who's interested in learning the differences or similarities between the two database engines. Okay. So what we have planned to talk about today is we're going to start off with a quick intro to Postgres, and then we'll compare the differences and similarities between Oracle and Postgres. We'll look at the architecture. We'll look at MVCC, which stands for multi-version concurrency control. We'll also look at the difference in the indexes between Oracle and Postgres, as well as the Postgres extensions, which are used to add additional features to your core Postgres functionality. And then we'll review some of the common mistakes we see when folks migrate from Oracle to Postgres, and then we'll end with some key takeaways. All right, so let's start with a quick intro to Postgres. So Postgres started as an ingress project at UC Berkeley, led by Michael Stonebreaker. It's written in C and was first released in 1997. And since then, it has been grown to be one of the most popular open source database engines. It's supported in all the major platforms, and it offers a wide variety of support via community or commercial support. And there's a major release every year, and the current version is version 16. So Postgres has a lot of features that are quite on par as commercial database engine like Oracle. It can support HADR, ACID compliance. It can do ACID transactions, partitioning, it supports tiered storage, and it uses MVCC where readers don't block writers and writers don't block readers. Also, Postgres, you can do online maintenance. You can do log-based or trigger-based replication. So Postgres has a lot of features in store that are on par with commercial database engines. So some folks migrating or thinking to migrate from Oracle to Postgres wonder if Postgres can support large database sizes. So here's a list of maximums that Postgres can support. You can see that Postgres can support a database size of up to 64 zettabytes and a table size up to 32 terabytes. So definitely Postgres can support large databases. But the takeaway here is you shouldn't have to concern yourself whether you're going to hit these near maximums, because if you are, you're probably hitting other limitations for hitting the database maximum size. For example, if you had a table size near this capacity, you should probably be partitioning. Or if you have a row size that's near this size, you might be hitting a limitation like the max column size, or maybe you're not using the right data type. All right? So now let's compare the similarities and differences between Oracle and Postgres. So there are some folks who are looking to migrate off of Oracle just due to the high cost or concern for vendor lock-in, or just the lack of ability to customize on Oracle. So Postgres has become a popular alternative, and folks with a background in Oracle find it an easy transition migrating to Postgres due to a lot of the similarities. So let's start with the terminology first, because there's some slight differences in the terminology between Oracle and Postgres. So to find a row ID, in Oracle we use the term row ID, where in Postgres it's CTID, which is a tuple identifier. And rows are tuples in Postgres, tables are relations. Data blocks in Oracle, where data is stored in pages on Postgres. And for redo, Postgres uses WAL, which is write-ahead logging. And for undo, multi-version concurrency control. And for SCN, the terminology in Postgres would be LSN, the log sequence number. All right, so now let's get into the comparison of the architecture between Oracle and Postgres. So here we have the architecture, the process and the memory side by side. And you see there's a lot of similarities in the architectural components. So shared buffers is similar to the database buffer cache in Oracle. This is where the data pages are read from disk into memory. Background writer is similar to log writer, or database writer, where it flushes the dirty disk pages to disk. And then we have the wall buffers, which is similar to the redo log buffer. And the wall writer is similar to the log writer, where it flushes the redo logs to disk. And then Postgres has a checkpointer process, as well as an archiver process. That's similar to Oracle's checkpoint and archive process. All right, so let's walk through the Postgres processes. So Postgres utilizes the multi-process architecture, which is similar to Oracle's dedicated server mode. And the three main types of process in Postgres is the postmaster process. It starts off as the primary process. This is the first process that gets launched at startup. And postmaster spawns the other processes and supervises them and restarts those processes if they fail. And the second one would be the backend process. And there's a backend process per connection, and these backend processes are the worker process. And its job is to fetch data and communicate with the client. And then we have the utility backend processes. And those are similar to Oracle's background process, where you have a checkpointer that checkpoints, wall writer that writes wall logs to disk, and auto vacuum that cleans up stale data from tables and indexes. So let's walk through the process how a connection is established in Postgres. The first step would be the client initiates a connection, and that connection request is sent to the postmaster. Their authentication would be performed. And postmaster is similar to Oracle's listener process, where it listens to connections on a specified port, and then it will spawn a backend process. And from there, the backend process calls back to the client, and then the connection is made.
Yeah, with Oracle, you have the share pool, and which you have the dictionary cache, you have the SQL cache, right? So one thing to point out with Postgres is that all part of those caches happens at the connection level. So the catalog cache is at per connection level, and as well as anything like a prepare statement, that's cache at the connection level. So with that, right, what we can imagine is with Postgres, connections is kind of an expense resource, right? Because similar to Oracle dedicated server mode, and essentially what it means is a user process will be mapped to a server process on the Postgres side, right? Even though the user process could be idle or doing some processing of business project logics, it's not using or submitting queries, and it's still going to hold a server process on the database side, right? And plus, because of the memory consumptions. So one thing about Postgres performance you want to kind of like optimize for is to manage your connections. And we typically recommend using a connection pooling solution on top of Postgres to scale your user connections. And the typical type of connection poolers, and there are many that are available out there, either that are community developed, like connection pooling solutions like PG Bouncer, and third party is PG Pool 2, and also if you run on AWS, and there is also a fully managed connection proxy called Amazon RDS proxy that's available. So any one of those will help to enhance connection management when you are running Postgres. Right. So if you were to ask me what is the single topic that you want to talk about when it comes to Postgres comparing to other database platforms, I would say it's MVCC. The way that Postgres implements MVCC really impacts a lot of like how it needs to be maintained, and it needs to be optimized. So what is MVCC, right? MVCC is multi-version concurrency control. And the problem that is trying to solve is that when you have readers and when you have writers and that are concurrently trying to access a row, then it can result in log conflicts, and which will create blocking, and in the worst case, deadlocking, which slows down the overall system performance, right? So what MVCC is trying to solve is that what if the reader and the writer are working on their own version of the data? So there is no longer issues with locking, right? Or at least minimize the chances of locking and to improve concurrency. Okay? So the concept of MVCC is not new, and it's common to all relational databases. And however, from an implementation-wise, the implementation it's very different depending on the different database engine. For Oracle, right, well, before we go into that, step back a little bit. The key implementation differences lies into two areas. One is that where are the multiple versions of data stored? Especially the older version of data. Where do we store it, right? And the second aspect that different databases implements differently is that what if we no longer need that version of data anymore? How do we clean it up, right? So those are the two implementation details that different DB engines treat it differently. With Oracle, the older versions of the data, it's stored in the rollback segment, the undo. And when an update happens, right, what Oracle does is to move that old version of the data over to the rollback segment. And if we need to recover and read that data again, we can recover, reconstruct the data from redo. And then we update in place. Right? And the cleanup of the old version of the data goes along with the undo management. So there's no kind of anything special that you need to worry about it. And similarly with SQL Server stores the versions of data in temp DB, and the maintenance goes along with temp DB. However, with Postgres, it's different. Postgres, when an update comes in, right, it always writes a new version. And then it just marks the old version as a dead row in Postgres terms, right, or dead tuple. And that tuple does not get deleted or removed from a space perspective. And the storage of that older version happens inside of the data table, right? And later on, a garbage collection process has to come in to clean up that data, make that space available again. So that's special about Postgres. And that's what's kind of causing the side impacts of every other maintenance activities that are special to Postgres that you want to know about. So when it comes to tuple visibility, that's driven by transaction IDs. In Postgres, each row has two system columns, xmin and xmax, right? And that determines if a row is going to be visible to a transaction. If we look at the DML activities and insert, when an insert happens, the xmin gets updated with the transaction ID of the transaction ID created the row, right? When a delete happens, xmax gets updated with the transaction ID to mark that this transaction deleted the row. And with an update, essentially we marked smax with the transaction ID, and then we also create a new row and mark the xmin with that transaction ID as well. So a row is visible, right? If you look at that equation there, if the transaction is created or the transaction started after the row is created, or that as well as for a row to be visible, it has to be active, as well as that it has not been deleted or in the process of being deleted. So now with the understanding of how the, Postgres manages and implements MVCC, one of the side effects of MVCC, it's what is called the bloat effect. And anybody heard of bloat in Postgres? Well, if you ever go into an interview for a Postgres DBA, you want to know what is bloat. And it's a very popular interview question. Right? Essentially, what that means is that the database exploded because of this side effect of MVCC. If you have a lot of kind of update and delete on the database, eventually your databases and may be occupied by these tuples, and it essentially exploded the size of your database. This definitely needs to be controlled and managed, right? Because if you don't control it over time, then the size of the database grows and your performance also tanks. I once have a customer come to me and says that, well, my query was performing well, since yesterday, and all of a sudden, today, it's running 2-3 times slower. What happened, right? Well, it turned out that overnight, there was a batch process that did a whole bunch of updates, and auto vacuum, which is the garbage collector, was turned off. And so the size of the data set exploded. And there's a lot of IOs has to be done, and process has to be done to get the query returned, and that's why the response time was higher. Right? So if you do see that type of performance problems, that's most likely what happens, because you have table or index both. And the process to control that or manage that situation, it's vacuum. And vacuum can be run manually, or you can set it to run automatically. So vacuum will reclaim space. So those space can be available for subsequent inserts. Right? However, one thing to know about is that vacuum will reclaim the space for subsequent DML processes. However, it's not actually releasing space back to the OS, right? Which we will talk about how you can release the storage space back to the OS later on. So hold that thought for a little while. And well, so how does vacuum works, right? Without going into the details and just very high level, vacuum essentially has two main phases. One is that it has to scan the heap, and remember all the tuples is essentially we can look at the city IDs, the tuple IDs in memory, and so that it can work on those tuples later on. Right? One of the optimization Postgres does to control or manage the number of pages that it has to scan through is by using something called the visibility map. So if the visibility map gives information of which heap pages needs to be clean, and so that can reduce the amount of pages that has to scan. But next thing that vacuum has to do is to vacuum the indexes and the heaps, and then finally it needs needs to perform the cleanup and free up the spaces that those data tuples used. And also, these step 1 to 3 may needs to be repeated if you don't have enough memory allocated to vacuum for vacuum to kind of go through these whole things in memory with a single pass. Or if your table is too large, then it also has to kind of repeat these steps. Right. Now, one of the key role for vacuum is to clean up those dead tuples, perform garbage collection. And vacuum also, in addition to that, vacuum also have other very important roles in play in Postgres. One of the very important things that vacuum does is update statistics. Well, we all know that query performance is based on statistics, right? So definitely a critical role there. And also we talk about the visibility map, and it helps to kind of improve the vacuum process, right? So it also updates the visibility map, update the free space map, and then another very important role, which is another concept that is very Postgres specific, is to protect Postgres from a transaction wraparound issue. So specific to Postgres, Postgres has this MVCC implementation, which is based on transaction IDs, right? Each transaction is assigned an ID, so maximum that it can support 2 billion IDs in the past and 2 billion IDs in the future, right? However, if you cross that 2 billion boundary, then the future and the past started to get mixed up, and what it means is data corruption, right? So you don't want to get into that situation, and the way to avoid that is vacuum. Right? So, and vacuum being so important, right? You definitely want some help to manage it. And so Postgres allow you to enable auto vacuum, which for a vacuum to automatically wake up and run periodically and clean up the data, looks at transaction wraparound issues, and make sure that does not happen, right? There are many tuning options that you can make your vacuum run efficiently, right? We did talk about earlier about memory, how much memory that you can assign to vacuum to, ideally you want it to go single pass, and then you don't have to repeat, right, the vacuum process. And also you can tune for the number of vacuum workers, right? In general, a single worker can work on a single table at any one time. Right? Started with Postgres 13. Postgres 13 introduced parallel index vacuum. So if you are at that right version, and then if you have large table, you have multiple indexes on the tables, and you can take advantage of that. Right? And then how is vacuum trigger? And the way it's triggered, it's also something that can be configured. It can be triggered if, say, X number of rows has changed on the table, or X% of rows has changed on the table, right? There's global settings, and there's table level settings, right? Obviously, if you have a table that is 10 terabytes versus you have a table that's 50 megabytes, and the settings will be very different, or you want it to be very different, right? 10% of a 10 terabyte table is still huge, right? for large tables, you want to look at options at the bottom of the slide and to turn at the table level. You can also control how long vacuum runs by setting the cost limit, right? Because if like you look at the vacuum phases, it does need to scan the table or pages, and it does need to perform like operations on indexes, and those are going to be I/O intensive, and it's going to be overall like resource intensive, right? So if you wanted to reduce the impact of vacuum, you wanted to look at these tuning settings to adjust based on your specific scenario. Right? One worst thing that can do is to turn auto vacuum off, because like I do have customers who say it's that, well, we see vacuum was the main process that takes the system resources and cause our queries to go slow, so we turn it off. Well, unfortunately, like at that point of time, it may seem that like turning off vacuum will make your query run faster because there's more resources to the query. However, over time, you will see that your query performance will start to degrade. And over time, the worst case that you can hit is the transaction ID wraparound, which if you ever get into that situation, the entire database will become kind of like unreachable, right? So you don't want it to go into that situation. So some of the like best practices of like how do you control the bloat of table and index, right? Essentially, it's a multi kind of like step process. First of all, you do want to have processes running to monitor the table or index bloat ongoingly to know the bloat situation. And if it ever goes beyond the kind of percentage that you would expect or you like it to be, then you will start looking into tuning vacuum and making sure your vacuum is running frequently, it's running effectively to manage or keep the percentage bloat on your table to a preferred percentage, right? And also, if you do get into a situation where you like have a highly bloated table and it's so fragmented, right? You would wanted to start looking at rebuilding the table, and with the rebuilds, either with rebuild of index, which you have an online option to do it, or that you can rebuild the whole table, and there is a PG repack extension, and that allow you to do rebuild online as well. Or if you can take time and take the database offline, then you can run vacuum full to vacuum and repack the table with that rebuild operation, you also can release the space back to storage. So that's a way that how you can shrink the size of the database.
All right, so let's talk about indexes. So when you migrate from Oracle to Postgres, there's going to be some indexes that may not work exactly the same as it did before the migration. So here is a list of some of the common Oracle indexes, say the equivalent that you would use in Postgres. So B-tree works exactly the same way in Postgres. For composite indexes, if you have that in Oracle, multi-column indexes work very similar. If you have function-based indexes, Postgres has expression indexes. And if you have invisible indexes, there's a Postgres extension that you can use called HypoPG that you can utilize to get the same functionality. So IoT is not supported on Postgres, so then you can use cluster index, which would be similar. And for bitmap indexes, There's a Postgres index that you can consider using called Brin index. All right, so here are a couple popular Postgres indexes that are available in Postgres that's not available in Oracle. Postgres has a lot more indexes to offer. So say you have a GIN index. These are optimal for full text searches, or Brin indexes are good for time series data. And here's an example of an index, of the GIN index. We can just simply create a GIN index, and here we can run a query, a light query using a wildcard search by just creating an index. We didn't have to implement any complex full search or anything. So the takeaway is, when you migrate over, your indexes might not work the same. There are some compatible indexes in Postgres, as well as if the indexes are not in Postgres, there's indexes that are very similar. Also, explore the wide variety of indexes that Postgres does offer. So now we'll move into Postgres extensions. So Postgres was designed to be extensible, and Postgres extensions are used to add additional functionality on top of your core Postgres features. Currently, there's over 1,000 extensions that you can utilize, and it's continually added more through the large community support out there. So once you load extensions into your database, it works as just like it was built in. And here is some popular extensions that are used from Postgres. For example, if you wanted to add vector search to your database, there's a PG vector extension. Or say that invisible index that I just spoke about, the hypo-PG. All right? So now let's cover some common mistakes we see when Oracle is migrated to Postgres. And the first common mistake is there's a misconception that Oracle applications can't migrate to Postgres because Postgres doesn't support synonyms. Postgres uses a schema search path instead. And what that is it's like a variable. You add your schema into it, and Postgres will search the objects within that schema order. Okay?
Now, with Oracle and Postgres, there are a lot of similarities, right? However, something that looks similar may not necessarily perform or behave the same. One thing to be aware of is how Oracle and Postgres handles nulls. And in Oracle, nulls essentially are equal to empty string. And however, in Postgres, Postgres evaluates a null as a non-value. So what that means is that if you were to do a string concatenation, or if you are doing a null comparison, or if you have unique constraints defined on columns that has nulls, you may after you migrate to Postgres, you may get some unexpected results. So let's go ahead and take a look at in the string concatenation scenario, right? Let's look at this specific query and select first name, concatenating middle name, concatenating last name, right? What happens with Oracle? Well, with Oracle, there's 10 rows returned. Everything is just nicely as you were to kind of expect it. With Postgres, we have 2 rows returned. What happened? Some of the columns has null values, and you cannot concatenate a null value column with columns that are string. Right? So how do you deal with this kind of situation? Let's look at what we can do on the Postgres side. So there are 2 options on Postgres to work around these issues. One is to use coalesce, right? So before you do the concatenation, you first do a coalesce. And all that you can actually use Postgres native function. In this case, it's concat_ws that will do the string concatenation for you. Right? So there are just like different ways of doing it with Postgres, but at the end of the day, you just need to be aware of these kind of differences. Another kind of more challenging part is unique constraints. And so let's say that you have a unique constraint defined on middle name. If you do insert and multiple inserts, and with the middle name that is null, Oracle will return a unique constraint violation because they are the same as empty strings. And in Postgres, because you cannot compare nulls, and null is not equal to null, so which means that you are not getting a unique constraint violation. In this case, it's going to be kind of like unexpected, right? Starting with Postgres 15, and Postgres 15 has supported a keyword that says null not distinct. So when you create your unique index, you can specify that keyword, and which allow you to get the same kind of like results back as that's Oracle-like. Right?
All right, so another mistake is migrating from Oracle to Postgres is the conversion of number to numeric. And most migration tools will translate it automatically. And here you can look at number and numeric. They look very similar. You have precision and scale. But if you look at the digits, the details below, Oracle only supports up to 38 digits before the decimal point, where Postgres supports a way bigger number of digits, 131,000. So it's important to know that when you have migration tools that migrate it automatically, go in there and look at your precision of your data type. If you have less than 9 before the decimal point, try to use int instead. Or if you say have 9 to 18 before the decimal point, try to use big int. And the reason for this is the size of this numeric data type affects the storage and performance compared to, say, the number that it's going to move over to for int to numeric. So it's very important to choose the right data type at the start. And another advice would be to never use numeric on your primary keys and your foreign keys. Instead, use big int. Okay?
Well, both Oracle and Postgres has different data types that supports characters, right? In Postgres, it has text and, for example, text and varchars. And people look at text and say, oh, that's just maybe a whole bunch of character data types, maybe larger data character data types, right? And Oracle has SCaLE, and which is for holding large character sets, right? So maybe that's equivalent, but it is really not. Right? If you look at Oracle SCaLE, that's a LOP data type, and worse, SQL Server has text, which is, again, a text character LOP data type. And so that's why there's so much confusion with Postgres text, right? People just think that it's another LOP data type, but it is not a LOP data type. And any LOP data types will require special operations to get like things such as length and to insert into it, all of that, right? But text data type in Postgres is actually identical to varchars. And it behaves and it operates the same as varchars. In fact, like, you can look at text as just varchars without a specific length. And with Postgres, varchars is implemented on top of text. From a performance perspective, text actually has better performance in most cases than varchars. So something to be aware of.
All right, now we'll talk about exceptions, which is another common mistake. So migration tools mentioned can convert a PL SQL code into PGSQL. And here you can see that the code looks almost identical. You have an exception on the left and on the right. But the main point to point out here is Oracle and Postgres handles exception differently. In Postgres, to handle exceptions, Postgres uses subtransactions, which are very expensive and heavy lift in Postgres. It uses a save point, so it can roll back to the save point. And having a lot of subtransactions, if you have a heavy loaded current database, it'll have a big performance problem. So make sure when you're using a migration tool where there's a lot of exceptions used in Oracle, that if it's migrated over, take a look and see if the exceptions are actually needed, because sometimes they're actually not. Like say if we used the same code earlier, if we removed out the exception, that raised an exception if there was a null, if you run the same function on Postgres, you'll see that you'll still get a result. Say the first one returns back the result of Michael, where the second one returns back a null value. We didn't need to have that exception. So we didn't need to have that extra expense of that subtransaction. All right. Also be aware that Oracle handles exceptions differently in terms of the exceptions raised. Like say, for example, Oracle uses that no data found or too many rows. So here we have that function. If we were, instead of to return back a null if it wasn't found, we want to return back not found. But if we run this in Postgres, that exception wouldn't be raised. It returns a null. So if we wanted to have the same response that like in Oracle, we're going to have to use the keyword strict. And here we see that we do get the result back a no, not found. So make sure if you're using migration tools that add the keyword into it and that the exceptions are handled differently. And with Postgres, it's very expensive with the subtransactions. All right. So now we'll end with some key takeaways. As mentioned, Postgres, you can improve your scalability with using connection pooling. And vacuuming is very important to performance. It's the topic that should be looked at. And also, there's some Postgres native features that just aren't available on Oracle. So you should take a look at the functions, the index types, and utilize that, as well as the extensions that are out there that could expand the functionalities to your core Postgres features. And the common mistakes that we mentioned with the migration is synonyms. Postgres uses the open search path instead of synonyms with the same behavior. NULLs behave differently between Postgres and Oracle. And there are a lot of data types that are converted over using a migration tool, and be sure that you're using the right one with the, in terms of storage and performance. And exceptions handled are differently in Postgres. Postgres uses subtransactions, which are very expensive. So remove the exceptions if you are able to. All right. So now we'll have some Q&A if anyone has any questions.
Yes.
Hi, thanks for the presentation. You mentioned in one of the slides that vacuuming full is not recommended. Instead, using PG repack or rebuilding index online. So is that mentioned stating, I mean, thinking the Postgres databases when it is a large Postgres database, or even for smaller databases, it's not, it's the same case?
Right. So the question is that when we talk about a rebuilding of index using PG repack or vacuum full, right, to rebuild the table, does it apply to only large databases, or does it also apply to small databases, right? So the answer is, regardless whether or not the database is large or small, it all depending on how broad the data pages are, right? Because even with smaller databases, and if your data is complexly packed, there are less IOs that you need to perform in order to bring the useful data in memory, and the efficiency of memory page will increase, and you can like cache more in memory, and the performance will be better if you do all of those things, right? So of course, I mean, it's not like you have to rebuild all the time, but it's just the key thing is to control the percentage of bloat. So to make everything essentially have a balanced system.
Try to meet you halfway and make questions go quickly. Number one, real quick, how widespread is the migration from Oracle to Postgres? And two, where's a good tutorial on managing the roles and permissions and schemas?
Okay, so the first question is how widespread is the migration from Oracle to Postgres? Being a Postgres specialist in AWS, and we see a lot of like Oracle on-prem to Postgres migration. I mean, the driving factors of it, it's pretty obviously, right? Especially in this economy, and organizations are trying to cut costs, and Oracle licensing is pretty hefty cost. And so that's why open source is becoming popular, and because of the flexibility and extensibility of Postgres and the like kind of large community supports, we do see a lot of people preferring Postgres as the de facto of open source database.
The other quick question is, does AWS or the open source community have really good tutorials to manage the roles and permissions?
Roles and permissions in Postgres.
For roles and permissions management?
So any tutorial, any guide?
Yes, yes. There are a number of AWS blog posts. If you were to kind of search AWS blogs on specific to the security aspect on how it manages, for example, IAM authentication, which is specific to AWS, allow you to essentially use the AWS account to authenticate against your Postgres database. And so on Cabot's authentication, which integrations with AWS managed AD, as with your on-prem AD, and there's a lot of information on that if you were to kind of interested in AWS, and yeah. There's a question over there.
Well, thank you for your time. I've used tools in AWS such as DMS to migrate from one Postgres database to another Postgres database. But from an on-premise Oracle database, can we use tools like Golden Gate to replicate data from Oracle to Postgres inside AWS, or is that not possible?
It's possible.
Okay.
So DMS, the database migration tool, can work with Oracle as the source and Postgres as the target as well. However, if you already have license for Golden Gate and you prefer Golden Gate over DMS, that's an option as well. So DMS will allow you to perform minimum downtime migration from on-prem Oracle to Postgres on AWS as well. And it's also a log-based replication solution.
Okay, thank you. With Golden Gate, I'm able to do bidirectional replication, so I have the option to fail back
Right.
if something goes wrong with the migration. Can DMS do bidirectional replication yet?
Yes.
Oh, yeah. Okay.
DMS also have options to do bidirectional replication. You essentially, it's possible to replicate or like migrate from A is Oracle, B is Postgres on AWS, and also from B to A. There is options to make sure that it does not do circulate replication. Although, like, we may recommend you to, instead of doing from A to B, B to A, it will be better off to do from A to B and to C, C as your fallback option. But that's the, like, the more details that if you are interested, we can take it offline and discuss more. Yeah.
Is there any extensions that you would recommend for related to performance tuning?
Extensions, is there any recommendations we will recommend for performance tuning, right? There are like many extensions that are performance related. For example, one very popular one is PG stack statements, right? Which allow you to look at more details of what has executed, right? There are extensions such as like HypoPG, and it essentially allow you to do what-if analysis for like creating indexes and without kind of actually creating the index and impacting the existing queries. And so there are many of them, and it just wouldn't be possible for me to name it all here, right? Yeah.
Okay, thank you.
Anyone else? Any other questions? All right, give it up for Trinity and Wanda.
Thank you. Thanks for coming.
Thank you. Testing. No. Why? Does it work?
Oops, it's fine.
Yeah, thank you. Thank you. Thank you. Thank you. Thank you. Thank you.
Let's hope it stays because
Sure, let's just keep it in here.
yeah, it should probably stay.
Thank you very much. Testing. I cannot hear myself. It's much better? Does it work? Yeah. Oops.
All right, hello folks, and welcome to the session on vacuum. Give it up for Devrim.
Thank you, Mar. So, in last year's PGConf New York and last year's PGConf EU, I gave a lightning talk. It was for 5 minutes, and I had 60 slides, 60. So based on the calculation, you can assume that I have about like 700 slides or so. But this time I have only 137, including the stuff. So, but I'll make it because I learned that we have an hour. So bear with me. Like I'm coming from a family where everyone in my family is a teacher. So like my dad, my aunt, everyone, just my sister, like everyone except me. So I try to I'm just trying to teach everything in here. Seriously speaking, my name is Devrim Gündüz. I work at Enterprise DB, EDB. I'm a Postgres expert. This is my title, at least. So I'm a Postgres major contributor. So if you have ever used the RPMs of Postgres in Red Hat, in SUSE, in Fedora, Rocky Linux, and Alma, this is what we support nowadays. I'm responsible for the official RPM repos. I used to be a website person in the past, but I broke it every time I committed something. I still have some commit access, but I try not to break it anymore. I also contribute to Fedora and Rocky. I'm a community member. I live in London, and nowadays, I'm also DJing, which is, I think if I get fired someday I have a backup work to do. Anyway, so I'll start with MVCC today, and I'm going to continue with the data snapshots, talk about vacuum, how vacuum is processed, and freeze, vacuum tuning, and vacuum full, and hopefully we will have some time for the questions. So let's start with a star. So what is this? I mean, I'm sure you all know SQL, right? Or SQL, whatever. What's a star? Tell me. Sorry? Wrong answer. Not everything. Sorry? Actually, it's for user-defined columns, right? So when you say select star, it doesn't select everything. It gives you the user-defined columns in a table. So it means there are some columns in the table. In every Postgres table where there are some hidden columns. So we will talk about these columns before we go into the vacuum processing. So how many people were here in the previous talk? So sorry about this, because there will be some duplicate content, but sorry about this, but I have to talk about this before going further. So in most of the databases, like all the databases have different solutions for concurrency control. In Postgres, for example, in SQL Server, I think called SCaLE or something, I don't remember, and other databases have different implementations. So this is the MVCC is the implementation of concurrency control in Postgres. It's based on snapshot isolation. So that's the definition in the in the glossary, let's say, the basic thing is readers do not block writers, and writers do not block readers. So this is quite clear, and you should also notice that we don't say anything about writers and writers. So for good reasons, writers block writers to the same column or columns. So based on, I will give more examples in the next few slides. By the way, these slides are going to be online, so if you want to take a note, of course, feel free to take a note. But it's already on my website, that I last updated 20 years ago. It will be probably on the conference website as well. Or you can just email me if you want. So we can have multiple versions of the same row in a database. So because when we run an update in Postgres, basically it's an insert and delete. We insert a new version of the row, that's where the version comes from, and then we mark the previous version as deleted. Actually, it's not physically deleted, we will get there. Okay, we will get there. And there can be some uncommitted transactions as well, which causes the multiple versions of the same row. And one of the most important things, probably, most of the people probably have heard, if you are dealing with Postgres, the date tuples, which we will talk about the next slides, in the next slide. So that's the side effect of MVCC. So, there are some, on the internet, every time there are discussions about which implementation is the best. Every implementation has its own problems. Okay, Oracle's implementation has its own problems. Postgres implementation has its own problems, or let's say side effects, maybe I should say. But every year in every release, especially in Postgres version 14 and 15, which I'll get there, Postgres made some great improvements over there. So let's start with some keywords that will make you sexy when you are speaking with other Postgres people. Hey, have you heard about LSN yesterday? Like, what about let's get some dinner tonight and talk about XID, TXID, stuff like this. So in Postgres world, when you say TXID, it's called transaction ID. It's a unique identifier. Currently, it's 32 bits. There are some discussions. Even I think discussions started before Postgres 15. So it's been a few years since the discussion started about adding 64 bits transaction IDs. I'll give some example about that one in one of the slides. So it's a unique identifier for each transaction, but it's a circle. First of all, it's a circle. So in a given time, when you get a transaction ID, it's either 2 billion. Not either. There's 2 billion in the past, and there's 2 billion in the future. So basically, it's a circle. It doesn't, there are some special, or let's say reserved transaction IDs. If the transaction is invalid, it's 0. This is reserved. And one is used during bootstrap, or let's say in the TB. And the second, the number 2 is, the 2 is reserved for frozen, which I marked in red because we are also going to mention in the next few slides. Basically, let's sum up this slide. We call TXID as a transaction ID. It's a transaction ID is acquired for each transaction in Postgres. It's a unique identifier for a given period of time. But the current problem is it's just limited to 4 billion, which will have some side effect, negative side effects, especially on the busy databases. We'll get there. So let's talk more about the transaction IDs. Let's start with selects, which is the basic thing. Actually, it utilizes a special transaction ID called virtual transaction ID. It's called virtual TXID. And you can get the transaction ID with the function within Postgres in this specific transaction. So, and it's stored in the header of each row. So remember the first question I asked you about star? Okay. Again, we define star as it gives us the user-defined columns for the table. However, in Postgres, like in many other databases, there are some hidden columns which helps us to store the data, do the maintenance, everything, or let's say basically do the transaction. So let's start with xmin and xmax. xmin is updated when we are running an insert, and xmax is updated when we are doing update or delete. And it is 0 when there is no update and or no delete with xmin and xmax. Again, there are some slides, in the next few slides, I'll give you some visual examples so that you can see what's going on. This is just for this theoretical part for now. So let's continue with the insertion first. Insertion is done to the first available space. Okay? The first available space is a critical term because when we learn more about vacuum, it's going to be more interesting. But first of all, let's say we have an empty table, and we, in order to even to delete or update something, you should insert the data. So let's start with the basic insertion first. Insertion is done to the first available space. By default, the page, not just by default, like 99% probably of the installations in Postgres world is 8 kilobytes by default for the page size. So for each 8 kilobytes, so it's done into the first available space. The xmin is set to the transaction ID because of this, as I told you. Xmin is an insert thing, and xmax is 0 for inserts. So let's take a look at a good example. So we first create a table with a single column, which is one of the best tables I have. Enough. One table, one column, one scotch, one beer. All good, right? And create a table. So in this transaction, first of all, if you are not familiar with Postgres again, in Postgres by default, every transaction, every statement is a transaction. So if you don't start the transaction with begin, like in the specific case, this is a transaction, this is a transaction, this is a transaction, this is a transaction. Okay? So we have basically 4 transactions in here. Anyway, so in here we inserted 2 rows to the same table, and another one in here, another one in here. So first of all, we have star. If you issue just a star, we would get 1, 2, 3, and 4. But in the specific case, in a specific example at least, let's say cmin, cmax, xmin, xmax. Let's start with the 4 columns. We will get there. We will get cmin, to cmin and cmax. So xmin, as you can see in C1, when C1 is 1 and 2, the xmin are the same. Why? Yeah, because they were inserted within the same transaction. So this is a transaction ID which actually inserted these 2 lines. Oops, sorry. Inserted. So as you can see, next transaction ID and next transaction ID. Of course, this is not a real real world case. In a busy databases, of course, the numbers would be not in a sequence. But again, this is for testing, so don't worry about that one. So 2 and 3. And then we have xmax 0 because we haven't done any updates yet. Remember the previous slides? When we do, it's going to be changed when we do some updates. And CTID is the physical location of the row in the specific page. So it means this is the page 0, which means the first page of the table. Remember, it's 8 kilobytes by default in most of the installations. So this is the first page, and this is the first first data in here. So it goes like this. Any questions so far? Okay, please.
When you say that the CTID says the page and which row it is, sorry. When you say that the CTID says the page and which row it is, how does it know how long each row is to know where that is in the page?
I'm sorry, can you repeat the question again?
So the CTID, you said it had the page number and which row it was in the page. How does it know how long the row is to know where that begins in the page?
Long?
Like CTID 02 there, is that byte offset 2, or is that byte offset 2 times?
No, it's the second row.
Well,
yeah.
right, my question is, so a page is 8K.
Yeah.
How big is a row? It's variable, so how does it know?
actually, hold on. I got a question now. In the next few slides, there's an example which is going to make things more clear for you.
Okay,
Okay.
thank you.
So let's go back to delete. Let's come to delete. So as I told you a few minutes ago, it's a logical deletion. When we say delete, it's not physically deleted. I mean, so my partners were always just angry about me when I say I'm going to do it in the next few months. They asked me to clean my room. I said, well, I'm going to do it later on because I'm a Postgres person, right? We want to delay things. So I said, well, logically, yeah, I cleaned my room logically, but I do the vacuuming later on. Okay, so that was the problem. So logical deletion, and because there are some problems with the delete, the reason is, even if you delete a row, another transaction may still need to see the previous version of the data. I mean, the undeleted version of the row, right? Let's say you are running a PG dump, but anyway, against a table. So let's say it's going to take 4 hours. Even if you delete a row which hasn't been backed up yet, even if it's deleted, it cannot be physically deleted because another transaction actually may need that row. May need that row is the key in here. And then we set the Xmax to the transaction ID. Hop, we have a that tuple. Let's see. This time I'm starting a transaction intentionally. Delete from T1 where C1 equals to C1. Oh, sorry. See? We don't see the data when we say when we run this regular select star, but we know that 0, 1 is there, right? And this is the first session. Again, I intentionally started the transaction in here. And while the transaction is running, within another session, I ran the same command. And now we can see something else in here. The other transaction sees the data without any problems, but Postgres internally puts an Xmax in here because any transaction ID which is greater than this one is going to see this one as deleted if when the first transaction is committed. When we commit this transaction, any transaction ID greater than this one for a while is going to see the data as deleted, but it's physically there. Okay. So back to updates. It's an expensive operation. It's insert and delete. Again, it's that tuple is a part of deletion. Let's see. And this is going to give us another hint about CTID. We updated a row where C1 equals to 2. Just to remind you, CTID was 0.242. For the next one, now we did an update, right? So again, update is, remember, insert and delete. So we inserted a row with a new transaction ID to the next available space. It doesn't have to be 5. I mean, in the real world, you are going to see some gaps because of the size of each row. It doesn't have to be 1, 2, 3, 4, 6, 7. It doesn't have to be like in a sequence. It won't be in a sequence eventually in the real world. And now we have, one is gone before because we deleted the first row. The second one is updated. Still, again, we start the transaction. Let's go to another session. Now we have another session where Xmax is deleted to, set to this transaction ID, 35. Let's come back to here. In the previous slide, xmean is set to 35, which is the insertion transaction ID. That's the same for the deletion transaction ID for the same row. Okay, for the same row. So there are two transactions two separate transactions which are seeing two different versions of the same row. This version sees the 20 version. This one sees the previous version anyway. Okay. So so now we need to consider the huge side effects of the excessive deletes and updates, right? Because eventually updates includes a delete. So in prehistoric way, so how many people started using Postgres before 8.3 in this room? Huh? See? So this is pretty much historical, like just the 3 of us or 4 of us. I think you also started Korai like before 8.3. Really? Really? I thought you were using before then. Anyway, so per this C file, there is a comment in here. Now they are overlaid in the same field in the header, and I got this information from doxygen.postgresql.org, which I found quite useful. It's a hidden website that I seriously love. Anyway, so let's talk about the data snapshots. It's not a physical snapshot, first of all. And when we say snapshots, we are more talking about the isolation steps. And this snapshot is created at the beginning of the transaction. It contains the committed data, and the uncommitted data is ignored within a snapshot. And this also, now let's start speaking about the vacuum, which is the topic of this talk. Okay, it's 20 minutes, and it's my first time talking about vacuum. I told you I have lots of slides. It determines the vacuumable rows or non-vacuumable rows in here. So data snapshots is important when there are some long-range transactions with like pgdump, which causes more problems, because when we have pgdump running against our tables or database, let's say, or schemas, whatever, if we have some dead tuples caused by deletes and updates, they won't be removed because pgdump, for example, in this specific case, or long-range transactions are going to need them. Okay, so long-range transactions are sometimes, often may cause problems for the database. So we have two parameters mostly. This one, they are disabled by default, and idle transaction session timeout might be important because, you know, when I was working as a DBA like a billion years ago, I had a co-DBA who started running transactions before he went to lunch, update a bunch of rows, and he committed the data after coming from lunch. So to overcome that problem, what did we do? We fired him. This is my way of solving problems. No, I'm just joking. Also, of course, we just disabled his access. So anyway, seriously speaking, that was a joke. So let's talk about visibility. So visible tuples, actually, we talk about visibility directly in here, where this row is visible to this transaction, and this row is this version is visible to another transaction. So basically, that's the visibility comes from. And it is done by comparing xmin and xmax, and based on the transaction IDs that the current transaction ID has. So only one version is available in a snapshot. So you cannot have both 2 and 20 of the same, for the same row in one single snapshot. The definition of visibility is the raw version. That raw version is already committed before the transaction time, transaction start time. So it is visible for us. If the raw version has been committed before we start the transaction, then it's visible to us. It could be insert or update. I'm sure we don't store commit times in Postgres, at least for now. And there are no rollback segments in Postgres either, because that's the Oracle implementation as far as I know. So let's talk about vacuum, which is I do every week in my home. but it's not the same thing anyway, right? It's a must-do maintenance process for homes. Sorry, it's the must-do maintenance process for Postgres. So if you are not, so you may think that you started. So I mean, when we talk about vacuum to the nearly DBAs, they said no, we never run vacuum, which is not correct. Actually, even if you don't, Postgres does something for you, which we will get there. We will get there. So it cleans up no more needed dead tuples. Okay? No more needed. No long-running transactions require this version of the row. Okay? Nothing is blocking this version of the row. So they can be deleted. Okay? We need to delete them. Now we are talking about physical deletion in this case. Remember, when we run the SQL version of delete, as I told you, it's a logical deletion. It doesn't physically delete data because we are lazy and we want to do in groups, like instead of cleaning one single glass when we are cleaning our home, I clean 10 of them just to save some time. This is the same thing. So it can run against a single table, a few tables, a database, a few databases, and all databases. So based on the parameters that you give, you can vacuum these ones. So it has two main tasks, and actually, I'm also going to mention about that one. It has 3 steps. It removes the dead tuples, and also it freezes the transaction IDs. So what does freezing transaction ID means? So remember, we have a problem. I mean, whatever the problem is, it's going to be the same problem in a larger scale, well, less scale, maybe I should say, even if we have 64-bit transaction IDs. Currently, again, as I told you in the very beginning of the presentation, it's a circle, right? Eventually, it's going to expire. Eventually, we will get there. Okay, we will get to the point where we will issue the same transaction ID to the database. Again, this won't happen. In the past, like very past, like probably before some people in the room were even born, when we didn't have a vacuum, we used to reach a point where Postgres used to shut down itself, so that we can start in a single mode and kick off vacuum vacuum manually to be able to continue running the database. Okay, so that was again maybe 20 or 20 years ago, maybe more. It does not block most of the queries, not all of them. Okay, I'll get there. First of all, concurrent vacuums to the same table is not allowed. So you cannot run vacuum against the same table. You cannot create an index when you run a vacuum. Okay, even if it's concurrent or the regular create index. You cannot create a trigger when you are running a vacuum. You cannot refresh a materialized view. You cannot remove columns from a table, and of course you cannot drop the table. Okay. So it doesn't block most of the queries. It's not going to block your day-to-day queries. No select, no selects. No, I mean, you can run selects, insert, update the list. It can go on. But the unusual stuff or irregular stuff will be there. And it creates I/O. And it's a part of the next few slides. And that's the problematic thing. Again, it cleans up the tuples. And it also cleans up index pages, which points to the date tuples. So we don't just clean up the table. If there's indexes against the table, index or indexes against the table, we also clean them up. Okay? And it updates visibility map and free space map as well. And if we pass analyze to vacuum, this is not the analyze and explain analyze. If you are familiar with the explain analyze in Postgres, it is something else. But if you pass analyze to vacuum, or you run a regular analyze anyway, it updates the statistics of the table. So let's start talking about the vacuum process. It's done per table, per page, first of all. It scans pages for date tuples, removes index entries pointing to the date tuples, and again updates these two. And finally, we will get there, truncates a lot pages of the table if the page is empty. So if the last page or pages are empty after vacuum, Postgres is going to truncate those pages to save disk space. Okay? And there's an extra parameter about that one, which I'm going to talk later on. It's going to update statistics. Again, we will get there. It's going to update catalog tables about the last update of the relation or the database, whatever. So again, as I told you, vacuum has 3 phases. The first phase is called ingest phase, also ingest phase. It scans the table, first of all, and creates a list of date tuples. So it knows which rows date tuples will be removed. It just creates a list at this point. It doesn't mean that it's going to clean every date tuple because of the visibility rules. If another transaction needs the previous version of the row, then it's not going to be marked as it's not going to be vacuumed. And the second thing is reads data into the memory. I mean the things into the memory, and it's going to freeze the tuples. Again, we will get there, and it's going to clean up the index tuples at this point. So as you can see, date tuple cleanup is not done at the first phase. Okay, date tuple cleanup is not done in the first phase. So it freezes the tuples, cleans up the index tuples, rows, which point to the data and remove tuples, and then done. So how do we control vacuum behavior? The most important thing, one of the most important parameters in this case is maintenance workmem. It can be set globally in PostgreSQL.conf config file, or you can configure it per session. I mean, if you want some larger maintenance workmems, then you can use this one. Vacuum can utilize up to 1 GB for maintenance workmem, which matches the on-disk data file size limit. So let me explain this one. What does it mean? In Postgres, a data file can be 1 GB maximum. So let's say you create a table, okay? It can span across multiple files, but each file can be 1 GB. As far as I remember, this limitation comes from the days where we could transfer between Linux and Windows, and when we transfer the files, the limitation was 2 GB or so. So we are below 2 GB limit. That's where the limit comes from, nothing else. I mean, not nothing else, but that was the motivation when this was set. Anyway, in the second phase, the good thing happens. First, the date tuples are removed. Now we are talking about physical deletion of the row, of the date tuples. So it means now that there is going to be gaps in the data files. Let's say we have 1, 2, 3, and 5, and let's say we removed 3 and 4. Okay? Eventually, we will have 1, 2, and 5, but the 3 and 4, the space occupied by 2 rows, now is going to be empty. But Postgres is going to know about this with the help of free space map, and the next insertion will be done to that space. Okay? So basically, if you don't run vacuum enough on a busy table, behavioral updated or deleted table, behavioral updated table, your relation may go like extensively larger, and it's not going to shrink. Often not going to shrink if you run regular vacuum. But it won't grow up either, because the next insertion will be done in the available space. So it's going to reuse that space, but the size on disk size will be larger. So it also updates the free space map, the map where the free space is, and the visibility map per page. And it also repairs fragmentation per page, and this is done. And finally, it does the index cleanup, update statistics and system catalogs per table. So if you look at the pgstat user table, we are going to see the data about when the table was last vacuumed, analyzed, auto-vacuum, and auto-analyze. It updates the statistics and system catalogs table. And truncase the final, last, let's say not final, they say last pages if there is nothing there. So eventually at the end of vacuum, the on-disk size may be smaller than the usual one. So what has changed in Postgres 16? In the previous version, it used to have ring buffers to perform vacuum. In 16, it saves shared buffers. It uses a different strategy as of version 16, and uses them circularly. This actually saves some space in the memory. So if you want to get more details, the link is here. I added the link for so that you can just read more details from there. And yeah, there's a problem. As I told you, let's say we started transaction ID 5, and eventually you perform 2 billion transactions. It's impossible, but almost impossible. But even if they were not vacuumed, if there were five transaction IDs in the same database, it will be corrupt in a second, because Postgres wouldn't know which one is greater than the other, right? So that's called transaction ID wraparound problem. In the past, it was a problem, big problem, because there was no auto vacuum, nothing to control this. And again, if the database, the DBase didn't vacuum at all, you would have lots of problems. But this past was, again, 20 years ago, not yesterday. So it's a must-avoid problem. And if the transaction is not if the transaction ID is no longer needed, there is no other transaction waiting for this specific row version. Remember Xmin and Xmax? Let's say we inserted something and no other transaction is looking for that one. Let's say we updated something, we deleted something, and nothing else is actually looking for the data at this specific time. At that point, Postgres freezes them, freezes the row. So now that specific transaction ID will be usable for us. Remember the 35, 34, 33 that we used in the past, we saw in the previous slides. So they can be reused again. That's going to prevent the transaction ID wraparound problem. And it uses specially reserved transaction ID too, which I mentioned in the third slide or fourth slide or so. This is always older than other transaction IDs, which is good because it means it's always visible for us. When we finish vacuuming, it's always visible for us, which is good. So at that point, first of all, the transaction ID is available for the upcoming transactions. Our data won't be corrupted, and we are fine. So again, as I told you, there's a patch for 64-bit transaction IDs. So I went to their GitHub repo and extracted these two sentences from there because actually having to vacuum frequently, freezing frequently it causes performance degradation because of the read and rewrite of all the not yet frozen pages while being used. Sorry, I didn't paste the remaining one. So basically, it's a problem nowadays. So I hope that page is going to be committed. But I'm not a committer. I'm not a hacker. I have no idea about the code. So we'll see. So let's talk about the vacuum problems. Please, these are in the order of in the PSQL, not in my personal order. So if you are familiar with Postgres and if you see it full and on the top, don't kill me, please, because we will get there. I'll skip this one for now. You can enable or disable freeze if you want. You can have variables. We always love variables, right? Because we want to see the details. We love spending our times while Postgres is doing everything. We love debugging everything. Even though we missed the output, we love seeing the things. Oh, things are processing. Just enable variables all the time. If you want to analyze the tables while running a vacuum, analyze means updating the statistics, updating the histogram of the data in PGSet tables. So, and then you can also analyze you can run analyze with vacuum. You can also skip locked pages, which is going to speed up the vacuum process, but then you may end up with unvacuumed portions of the tables. But again, it's going to speed up the vacuum process because it's just going to skip the lock. This is disabled by default, by the way. You can disable index cleanup. Don't, but if you want just to process the main table first because of good reasons like performance problems and etc., you can turn it off, but by default it's on. You can just process the main table, which is on by default, but there's a toast table oversized storage attribute technique. So there are toast tables in Postgres. You can disable vacuuming that one if you want. Not encouraged, but again, if you have some problems that you need to solve immediately, please, you can also disable that one. And you can disable the truncation process if you want. It's on by default. And in the next few releases, last few releases, you can use parallel jobs to perform the vacuum so that it finishes more quickly. In the previous versions, we had one single one. Starting version 16, we have 3 more. And it's also available in 17, of course, as well. It skips the database statistics, means don't update the database-wide statistics just to save some time and other things. Or just update the database statistics, do nothing else. So basically, you can run skip database stats if you are running vacuum against multiple tables in a single script. Run with skip database stats, blah blah. Finish it first, and the last line could be vacuum and only database stats. So then it's going to save some time for you as well. And then you can also set the buffer usage limit, which is also set by the vacuum buffer usage limit in Postgres.config file. So vacuum and vol, if you are familiar with Postgres already, vol is logging of transactions. It's called write-ahead log. And all the modifications are logged, all the physical changes are logged to the vol files. So since vacuum does page modifications because it's doing some physical changes, especially on the second and third phase of the vacuum process, it's going to create some vol I/O. It's also used because we need the same thing for crash recovery, and we also require the same things for the replica servers as well. The replication is based on vol in Postgres, and most of the replication is done with the vol records. So we need everything to be logged to the vol files. Eventually, vacuum causes extra I/O pressure on the vol files, which is going to affect your backups as well, because like all the tools like PG Backrest or Barman or other stuff are going to back up your vol files for continuous backup, and you will need to have more space for these ones. So what about vacuum and replication? You can use replication for, say, backup purposes, slightly backup, not backup, but sorry, like failover or switchover scenarios, or running some read-only queries against the database. Okay, so when you are running some queries which last longer than usual on standby, we have a problem. The problem is, rows are updated in on the primary, and vacuum kicks in. We are in an update, okay, on primary node, and vacuum comes and deletes that one. So it's deleted on the primary. As I told you in the previous slide, it is written to the vol file and it's replicated, right? So if there's a long-running transaction on the standby which requires that row, eventually we lose a row. And at that point, this is default, by the way, Postgres just cancels the query on standby. It says canceling statement due to conflict with recovery. So of course, there's a solution for this, which is called hot standby feedback. Hot standby feedback gives the primary server about the long-running transactions and says, please don't these on primary until I'm done. And the negative side effect of this is bloat. Because on the primary, Wacom won't do its job, won't be able to do its job. So there will be bloat on the primary node. So again, there's a trade-off in between. So pick up whatever you need. Yeah, bloat will increase. So there are a few things that you can use the throttle. You can use throttle the Wacom process. By default, there is no throttle on the Wacom process. So if the Wacom, the page which will be vacuumed is in the memory, the cost is 1 by default. These are default values. If it's 30, it's 20. It's missed by, it's going to be read from drive. This is 2. And if they reach, I mean, these three parameters reach 200 by default, Postgres is going to, Wacom is going to sleep this many milliseconds and then continue. Okay? So this is how you throttle the Wacom process if you are short of I/O. Again, this is disabled by default. This is going to slow down the Wacom process, but again, it may be useful for you. It may be useful if you have a short of I/O. So it is going to result in less I/O, but then Wacom is going to take longer. Less I/O over the time. Eventually, it's going to do the same I/O. I feel like I'm like too old. I'm not young, but I remember the days that we had we didn't have auto Wacom in core. So it's been there since 8.1. It's like forever. Anyway, it kicks off. There's a process called auto Wacom, which also does auto analyze. So it is kicked off based on some parameters in Postgres config file or per table. You can configure them per table with alter table command. And also it kicks off auto Wacom to prevent transaction either wraparound. So if there's a DBA who doesn't run any Wacom, nothing else, based on the configuration parameters in Postgres config file, Postgres is going to start auto Wacom to get rid of the transaction ID wraparound problem, and this is a problem. When I say problem, let me explain what it means. First of all, you cannot kill this process. I mean, it's going to restart even if you kill it. And often, by Murphy law, which is also available in Postgres, it's going to kick off in the busiest time, right? So make sure that you don't disable it. Oh, yeah, it's in here, in the slides as well. So it may or will prioritize some busy tables, and some tables may be untouched. It may cancel itself if there's when there's a higher log level is required by another transaction. So you may say auto Wacom task is canceled in the logs because someone wanted to create an index. So eventually you may end up, don't trust on auto. I wouldn't trust on auto Wacom. This is my idea. There are other good Postgres people out there who think the opposite, but I wouldn't trust on auto Wacom just by itself. So there are some parameters which control the Wacom, auto Wacom process. You can, as I told you, you can tune it per table with alter table command, all the auto Wacom parameters. So you can just disable auto Wacom for some like static tables, like say states in the US. You can just disable auto Wacom on that one because it's not going to change. But if you are keeping the number of women and children killed in Gaza, then you should just keep it enabled because it's updated every day. So Wacom and auto Wacom, they can live together. I I always use Chrome-based vacuum just in case it's done in a good way. So vacuum full. Do you know this song? No. Yeah. Cut my life into pieces. This is my last resort. Okay? This is seriously last resort. Because it rewrites the table. Means it locks the table. When I say lock the table, it's an access exclusive lock, which means it's going no inserts, no selects, no updates, nothing can be done against this table until vacuum full is finished. That's why it's last resort. But if things have gone too bad at that point, you may have to need it. But this is the only transaction that runs against the table. Requires this space similar to the table size. Okay? It's a downtime. So there are some alternative exists. PG repack and PG squeeze. PG squeeze is probably much better than PG repack because PG squeeze has a sort of cron-ish thing that you can also schedule the maintenance process within Postgres. Okay, so again, we love verbose output. This is one of the verbose outputs. I think in Postgres 14 and 15, some people added more output in here. This is one of the things that I really like. One of the views in Postgres, which is called PG set progress vacuum. It shows you what is being done, how is the process is going, and etc. Yeah, I'm finished, almost done. So first of all, thanks for coming here. Do you have any questions that I don't know, I cannot answer? Thank you. Do you have any questions that I don't know the answer of? Thank you.
My question is, you mentioned that vacuum does it on a per page. What if I have like 3 pages with 1 row inside them because of deletes?
I can't hear you.
Oh,
Sorry.
can you hear me now?
Yeah, thank you.
Okay, so you said that vacuum does cleanup of the per page in a table. What if I end up with, because of deletes, 3 pages with 1 row in them, 1 record in each page?
I'm not sure.
Does it gonna clean up and compact the table, or I have to rebuild it? So, pages, yeah, because of deletes. I used to have like full pages, and then they deleted the rows, and now I have 3 pages, 1.
Yes, 3 pages. So it's going to. I'm sorry why. I don't know why I couldn't understand both of the questions today. I don't know why. Just blame jet lag or
So
something.
you start with 3 pages, all full.
Okay.
And because of deletes, there is only 1 row in each page left.
Okay.
And never vacuum the table. If I run vacuum, is it going to make 1 page out of it?
No.
How do I get 1 page out of it?
Full.
So the only thing is vacuum full, which will do that?
Yes.
Okay.
But again.
Yeah, but don't do it because
Yeah.
it clogs the table.
Again, all the new inserts are going to be done over there in the
No, I'm talking about
space.
static pages. That's
Yeah.
mostly used in like warehousing.
Yeah. Another question that I want to understand and won't be able to answer? It's just a bad day. Anybody else?
Have to speak into the mic.
I think it's also being recorded as well, so we need the microphone.
Yeah, I have a follow-up to that last question. So let's assume now that there is 1 row in each page, in those 3 pages, and I update those rows. Now, updating them will move them most likely to a different page?
So if, let's say you updated the row in the 3rd page, okay? It's probably going to insert the new version to the 1st page, the first available page. So it's not going to create a 4th page. It's going to use the available space on the previous pages.
Okay.
Actually, that's why we run vacuum, to be honest. So vacuum, let me explain it in a different wording. When you run vacuum, it makes those space as reusable, okay, for the future transactions. So if you have some space on the first page, Postgres is going to try inserting that row to the same page if there is enough space, of course. Okay, I mean that's a bit complicated, but it depends on depends on how much data are you going to insert, how much available disk space over there. It may create a new one if there is no available space in the previous 3 pages, but often it's going to try to use the available space in the deleted in the vacuumed pages. I think they will be available in SCaLE website along with the schedule, or you can just email me. Is devrim.gunduz.org, devrim@gunduz.org.
With or without the ULLs?
Of course, without. devrim@gunduz.org. I mean, I'm sure if you Google my name, you'll find an email easily. You can email me, but I'm sure it will be website. I mean, I'm sure it will be on the conference website. It was a case for last year. I mean, an older version is also available in other conference websites as well. I mean, I gave this talk in other conferences, but it's all, I mean, more or less it's like pre 16 version of the same talk. The basic infrastructure is also there. So I do something after my talks. There's a Twitter account which is cheering for Postgres, which actually raise your hands and we take a selfie with the attendees that I have. So if you don't want to be included in the picture, you can leave now. Otherwise, I'm going to go take a selfie. Again, this will be posted on social media, just to let you know. So if you don't want to be in the picture, let me know. Oops. Thank you. Thank you.
Do you have a recommendation how to turn off, how to vacuum through no, but through the busy days of the day? By cron job? No, but how do I say, hey, how to vacuum? Don't run from this hour to this hour, because then I know that...
Auto vacuum, right?
Yeah.
No, you can't. Again, the only thing you can do is alter
Increase
table.
the cost.
Alter table.
No, but I don't want to do it per table, I want to do it. So I have like, I know it's...
Or increase the threshold.
Yeah, so, and then I have a cron job that changes the thresholds up and down per the database.
Or you can increase the thresholds, which we did for the bank customer. So they were just running from 9 a.m. to 6 p.m.
I'm a bank customer.
So what we did was increasing them just significantly, dangerously higher, so that they don't hit by any auto vacuum during the day. So after 7 p.m., we use manual vacuum to process the data.
So you disabled the auto vacuum entirely?
Not entirely, again.
But if you increase the cost per plant, wait, so the cost will be like this if there is no activity, it will still run because there is nothing else to compete.
Yes.
So even though my cost is too high, I will run.
Yes.
So by raising the cost on the auto vacuum, you are saying don't run if, okay.
If it's still not going to reach that level,
then
it's fine. It's fine. Then
even if the cost is that high, there's nobody else to compete. So except if there is a gap in your processing time, and it kicks up at that time.
I know we had the same problem, but I mean,
wish that they had a functionality to say
which version are you using?
maintenance 15.4.
15 is great on that point. I mean, we had this problem with the bank with 9.2, and enterprise actually pushed the fix for 9.3, just for the specific purpose. So because there was a problem with number of tables over there, so they were using auto partitioning on the table. So it was a big problem for them for the auto to vacuum. So what we did was basically increase it significantly higher. Yeah. I mean, on the other end, you can use alter table, but it's going to do some locking when you do alter table.
Yeah, when you do the outer.
Yeah.
But the idea is
I
to
would
be
not
able
do
to
it.
do maintenance windows where you say don't do vacuum during this time and do them during.
Yeah.
But the cost is also.
Sorry. Sorry. How are you? I mean, are you speaking now or in an hour?
In 12:30. Yeah, 12:30.
Oh, sorry, I thought it was just 2 p.m. or something. Yeah, the break.
Oh,
So how are
the
you?
lunch break is 1:30. Yeah, well, I'll find you and Mark. Yeah.
Great. Sorry. Hello. Sure. So it's on manager, right? Okay. So it's when I'm arriving, so if it's after 6 p.m., then that's fine. Okay, then
Richard,
then
I
it
don't
works.
believe we have met before.
Yeah, I've seen your name around a lot.
Okay, I'll take that as a good thing.
You were at EDB
I used to be at EDB at one time, yes.
until when?
So I had 2 stints. So I was there since the beginning in 2003 till 2011.
Okay.
And then I left, and then I got acquired back into EDB as part of the second quarter acquisition.
That,
I will have
oh
to get
yeah,
back.
okay, there.
No.
Yeah.
So, but yeah,
Same decision.
I left very soon after I left a few months after the acquisition.
Okay, I see. And then now you're at Crunchy?
So I run a professional services firm by the name
Oh,
of
totally.
Informatics.
Oh,
So
okay.
professional services focused on Postgres.
Oh, I see. Okay. So are you in North America?
No, I'm actually based out of Pakistan.
Oh, Pakistan.
Yeah, that's my hometown.
Oh, cool. Wow. Okay.
And Dubai
Well, yeah.
and Maldives
Well, I thought we decided on Bali.
and Bali. Yeah, and Bali and Maldives, please.
Yeah.
PG Day Maldives.
Yeah. We took a bit of a leap with the Gaza reference, right? Yeah.
Let's do it.
I'm just looking around and I say, somebody registered this, it's just somebody. But I'm glad you did. I'm glad you did. Yeah. So, okay, one of the things that I am supposed to do is to set this microphone for the next speaker.
Oh, is that
So let me
right?
do that.
Oh, okay. Thank you.
Just make sure that this is all cleaned up.
Forgot that I have a HDMI port now.
Oh, you don't have an HDMI?
Oh, they do. The new ones do.
Yeah.
Yeah, the old one that I had before didn't have one. It just had all the USB-C ports in it. The dongles for everything.
Well, I have this Mac.
This Mac, yeah.
Okay. Well, one of the things I like about Enterprise Z and being a contractor is I have an actual laptop, not a Mac. So I have Asus in here.
Oh, come on. Oh, come on.
No. This is like powerful. This it's really much better than anything else.
I'm sure it is, but come on, you cannot,
And I
you
can-
cannot call Mac not an actual laptop. Come on. No? Hello, folks. So, did anyone come in here in the hopes of riding an actual elephant? Well, sorry to disappoint you. Well, give it up for Richard.
All right, thank you very much. Can you all hear me? Okay, cool, thank you. All right, yeah, welcome to this talk entitled Riding Elephants Safely. It's basically about working with Postgres when your DBA is not around. As you may know, the mascot for Postgres is the elephant, so you want to work with your database without breaking it and taking your application down. So we'll just go about, we'll be talking about that today. So just real quick about myself. I am a software developer and I was a support engineer at Enterprise DB since 2015. We work with a lot of large-scale clients like insurance companies, banks, military, governments. And yeah, I think I just want to share from my experience what a lot of our customers had to deal with. So hopefully this will get you oriented with Postgres if you're not already familiar with it. These days, I'm actually using Postgres behind some apps that I'm writing in Golang and Python. And before that, I was a web developer using Perl before I switched over to being a DBA. And I've been working with Postgres since 2002, and I really like using this database. I was first a MySQL user, but then after working with Postgres, I couldn't go back. So yeah, this talk, is this for you? I think if you're a software developer or a QA engineer, a data scientist, someone who writes applications that uses a database, but you don't actually interact with the database itself on a regular basis, this talk is for you. Maybe if you're interested in being independent from someone else who manages the database, so if it's like a sysadmin or a DBA, someone who manages these environments and you're actually not able to use them hands-on on a regular basis, this talk would be for you. Maybe your DBA is on vacation, or maybe your DBA quit or got laid off, or if you've never had a DBA and you're just inheriting this database that you have to work with, this talk is for you, okay? Yeah, so what are we going to talk about? I can't do justice to Postgres in 1 hour because there's so many things to go over. So we're going to limit ourselves to just a few of these topics, so that way at least you can get your feet wet, you can find your way around the database, maybe even the server itself. Yeah, so we'll be talking about just a handful of these things, and I'm going to detail them here. Okay. First, we want to be able to log into the database, and maybe even start and stop it if we need to. Second, we want to be able to take a backup before we run into some kind of catastrophic damage. And then we also want to be able to diagnose some pretty common performance or stability issues by reading through the logs and through some views within the database. And then we want to be able to identify any schema changes that might improve the performance of the database. And then understand the file and directory structure within on the disk, okay? And most of these commands, if not all, I didn't keep track of all of them, but most of the things that I'm going to share with you today can be done while the database is up and running. So you will not need to restart it, you will not need to have a downtime. We want to keep the database up and running because you are not the DBA, someone else is, and you don't want to be responsible for taking the database down, okay? So just to kind of, if the database is not running, we might need to start that up. So we'll take that first step of getting the database started, okay? Now, for the majority of users out there, you guys, you all might be able to SSH or use some kind of remote connection into the server. If you are using a managed database like RDS, you'll need to start and stop that from the console. Now, assuming that you can actually SSH into the machine, most of them are using Linux, and we're at a Linux conference, so SSH is probably the way to go. You want to first perform some sanity checks before starting it up. So if the database is down, you log in. You want to check to see if the disk space is, if there's free disk space to be able to start the database, because sometimes database will crash because it ran out of disk space. So you want to perform the df -h to see if any partitions are full, and then address those partitions accordingly. And then you'll also want to look at your database logs. Usually, syslog will help. Otherwise, you might need to find the logs, and I'll try to help you with that as we go on. The database logs might have some messages that explain why the database isn't running, like it crashed, something else happened, somebody shut it down on accident. So you want to know why it shut down before you try to start it back up. Okay. Now, once you figured all that out and you determine that it's safe to start the database up, you want to use systemctl and start Postgres. Depending on the distribution of Postgres or the distribution of the OS, you may need to use PostgreSQL dash version to start it up. Brute force, if you don't want to use systemctl or you can't, you can use PGCTL. And PGCTL is the command that is used by systemctl to start the database. So if you don't want to use it, you can just start it up manually yourself with PGCTL. However, you'll need to know where the PG data directory lives in order to start it up. Usually that's if you're using the community version of Postgres and not a redistribution by another company, it should be in var lib pgsql / and then the version and then data. And then again, if you're using Ubuntu, it might be a little tricky to figure that out too. So you'll need to figure out where PG data is. That is the data directory where all the data lives. If you don't know it, try asking your sysadmin, ask your DBA, get that information beforehand before those people disappear. Okay? Yeah, so PGCTL will start the database. Now, if for some reason you need to stop it, there are 3 modes to stop. When you pass it with no arguments, it'll go into a smart shutdown mode, which basically really cleanly shuts it down by waiting for all the sessions to disconnect, and then it shuts down. However, if you use the mode fast, MF, what that will do is that will, blanking out, sorry. I think that will stop it'll wait for all the queries to disconnect, all the queries to finish, and then it'll stop. So the first one, it waits for all the sessions to disconnect. Second one, waits for all the queries to finish. MI is immediate. It actually simulates a crash of the database. It just shuts everything down. And then if you ever have to start it up again, it'll start in recovery mode, which takes a little bit extra time. Okay? Now, so now that the database is up and running, we want to be able to connect. So what you're going to need to be able to connect, you're going to need the host name, and you're going to need a port, which is usually 5432, but in some instances, it could be a different port number. So you'll need to use maybe like netstat or something to figure out which ports, which port is listening on. And then you'll need a username and password, and then you also, you might need to check the PostgreSQL.conf file to figure out if any of these don't, if the port number is not standard, and then if your listen addresses is not set to star. Okay. Connecting tools that we use to connect. The one that I'm going to use today is called PSQL. This is the default command line interface, and if you use this, you basically can use just put in some queries just like any other like a bash interface sort of. You just type in the query, you press semicolon, and press enter, and then the queries run. Now, if you need to use like a GUI, we would recommend pgadmin or dbeaver. These are some pretty popular graphical user interface that allows you to connect to the database and run some queries. Okay. So let's say I connect, right? So I connect with PSQL. I pass in my host name, and then my username and my database name, and then it just assumes that it's using 5432. So you don't need to pass it in a port if it's going to be the standard port. Now, once I log in, I'm presented with a prompt with the database name, and I can do a bunch of these / commands to figure out, kind of figure my way around. The first thing I can do is /L, which lists all the databases that have been created for this machine. The one that I'm going to be using is going to be edbadmin. Postgres is a database that's created by default. Some people use that by default, but I highly don't recommend that, just for the sake of, I guess, security. And then template 0 and template 1 are databases that are provided by Postgres as kind of like a bootstrap way to create other databases. So you don't want to use those, and you don't want to delete those either. If you actually modify template 1, any other database that gets created will have whatever's in template 1. So if you create a table in template 1 and you create a new database, that table is going to show up in that new database. So you don't want to touch these unless you don't want to touch them at all. Okay. All right. What else can I do in there? Okay, so I can do \d, which describes all the tables and sequences that are visible to me. Okay. As you can see, if I do \c, I only see these two views. I don't see any tables. And the reason why is because some of my tables actually don't exist in the public schema. By default, my namespace is going to be public and my username, which is going to be edbadmin. So if I wanted to, I can type dn, which describes the namespaces or schemas. And here we'll see I have a namespace called my schema, and then public, and the results. So if I want to actually be able to see those tables that are in those schemas, I'll need to change the search path. And I'll show you, it's just search _ path, and you'll need to set that on the prompt. Okay? So now we've connected, we can kind of see what tables there are. What is going on in the database? So usually when somebody logs in and wants to use the database, it's probably because they need to figure out something, right? Figure out what's going on, right? And the way that you figure that out is by using this view called pgstat_activity. And what this does is it shows what's going on in the database at that very instant. And if you're using RDS or Google Cloud, that table might, or the view might actually have limited visibility. It's basically because you're not a super user. So if you can get super user access to be able to view everything, that'll be very helpful. Okay, and then if you actually have access to PSQL, then you can show log directory, and that'll show you where the logs are. And then that directory will contain all the text logs of various things that are going on or happened in the database. Okay. And then RDS will cloud-based distributions will have the logs available if your sysadmin made it available to you. Okay. Okay. And once you've decided, once you've figured out what's going on, and you might need to actually like stop a process or stop a query, you can actually use these two commands, pgcancel_backend and pgterminate_backend. pgcancel_backend will cancel a query. So the query that's running will get canceled, and then that session stays open. However, if you find that insufficient, like for some reason that's not resolving the problem that you're experiencing, you may want to use PG terminate backend on that process ID. Okay, so how do we get the process ID? Okay, so here's, I'll show you this, right? So here's a view of PG stat activity. As you can see, it's a little bit hard to read because it's really wide. It's got 3 lines full of column names, and it could be a little tricky to read. So one tip, you can use \x to turn it transposed. So you can show all the columns as rows, and then you see one record at a time. Okay, so now I do PG stat activity again, and then I can see this PID is running out of vacuum, and then this PID over here is, actually that's me. That's my query, right? So like let's say somebody, you look at this view and you say, oh, this query's been running for a very long time, or it's been idle and it's actually holding a lock or something like that. You do PG cancel backend or PG terminate backend on this PID, and then it'll do what it needs to do. So here's a quick example. So let's say I get in here and I look for everything where it's active or idle in transaction, and I see that this vacuum full is active and it's waiting on something. It's waiting on a lock. So it's running, but it's basically stuck, and it can't go any further. And you look at the second row, you see that, oh, there's this other query, this select query that is idle in transaction. And okay, so something's a little fishy, right? So what you can do is you can take this view and this information from PG stat activity and cross-reference it with PG locks, right? And you look at which locks are not granted. And here we go, this one is not granted, and you want to find the relation or the table that has the same ID and find where it is granted. And it turns out, in this particular example, I actually have another session somewhere that actually did a begin and it locked the table in exclusive mode, and then it does a select. And the moment you do the select, the table's locked, and then that's why it shows up in this view that this query ran, right? But it's waiting on the client, so it's actually not an active query anymore. Okay, so that's just it's just idle in transaction. So I started the transaction, and I ran a query, and then I walked away for lunch, and then now it's blocking the vacuum or blocking whatever else, whoever else is using the database, right? So you want to definitely look for idle transactions, cross-reference it with PG locks, and then that'll help you figure out what needs to be done. And then because this is not a query, it's just sitting there, then I have to use PG terminate backend. So I do PG terminate backend on this PID, and then that session ends, and then my vacuum can continue. Okay? All right, so that's a very important part of working with the database in terms of making sure the app keeps up and running. Now, let's talk about configuration for a little bit, okay? Configuration is all contained within the PostgreSQL.conf file, and that is within PG data. So that's why you need to know where that PG data folder is. I think for Debian, it's actually in /etc. So yeah, depending on the distribution of Linux you're using, you may need to look outside of PG data. Okay. There's also a file called PostgreSQL.auto.conf. And that is actually something that humans should not be working with, because the alter system command will edit that file for us. Okay, so if you're in PSQL and you want to change your configuration, you can do alter system set, whatever configurable to whatever value you want. That's a very convenient way to change the configuration. However, I think it's limited to certain users. So if you actually have file access to the PostgreSQL.conf file, it's probably better. Okay. Now, what is the current state of configuration? Now, sometimes some people will edit the PostgreSQL.conf file and then forget to reload it or forget to restart the database. So what's actually loaded in Postgres is not matching with what's in PostgreSQL.conf. And in that situation, it can cause a lot of confusion. So what you want to do is you want to get into PSQL and run show all, and it'll just print the whole table. This is the current configuration that's loaded. These are the current values. Okay? And, okay. So the configuration, you can change some of it without having to restart the system, so without a downtime. And I'm going to go over a few of those with you. But just to get a list of what those like parameters are, you can actually run this query. Select name setting from PG settings where context is in SIG-hub or user. So if you this will provide a list of all the things that you yourself can change without actually actually requiring a downtime. Okay, and all you have to do, if in the user context, you can say just set parameter to value, and then it'll go. So like I guess the easiest example would be workmem. So workmem is set globally in your conf file, but it can be edited at a user level because you want extra work memory to do sorting or joins on a query that is particular to your use case. So you would say set workmem to 100 megabytes or whatever, right? And if you want to actually set it globally, then you say alter system set workmem to and then the value, and then you do a SIG-hub on the postmaster process, or you do a PG reload comp. Okay. All right. Yeah, or the other options is actually find the PID pertaining to postmaster, and then just do a kill hub. Okay. So some of the useful configuration parameters, I talked about workmem. I'm just going to quickly go over a few of them with you. Some people will wonder why I don't talk about shared buffers and max connection. These are the two most important parameters in your database, but they might not be useful to you if you're not a DBA, because changing these require a downtime. You don't want to have a downtime, so we're not gonna go to those in depth. Now, search path. So like I mentioned, the namespaces. Like if you, by default, search path is public and your username. If you want to add to it, you say set search path to, and then a comma delimited list of all the namespaces you want to be able to look in. You can change that in the PostgreSQL.conf and then reload the database, and then you'll have like a larger set of namespaces that you can look at by default. Workmem, like I mentioned earlier, is just memory allocated to sorting and hashing. You want to be careful with this. If you change it in PostgreSQL.conf, it could affect other users. Like let's say you have a machine with 64 gigabytes of RAM, and then you say workmem equals 1 gigabyte. Every session gets 1 gigabyte. So if you have 100 sessions using the database, you're gonna run into memory issues, and you might have a crash. So set the workmem low, or just kind of like the average, and then on a per session basis, you set the workmem manually to whatever you need for your queries. Okay. Maintenance workmem is also very. It could be potentially useful if you're trying to deal with a performance issue. Maintenance workmem is similar. It just sets memory for your vacuum to be able to work with it. I'm sorry? Oh, I'm good. Yeah, it's okay. I'm sorry? I put the cover on. Oh, I think it's underneath the podium. Yeah. Sorry. Yeah, that's good. Yeah, thank you. Okay. Yeah, thanks. And then some other parameters that you can change without having to change the restart the database are some of the log parameters. So this gives you more visibility into what gets printed into the logs. Okay. Now, let's see. So these ones, I'm not going to go into them too much, but log line prefix gives you more information about the session that caused that log entry. And the log checkpoints might show you whether you're checkpointing too much or and causing IO issues. And then log connections, log disconnections will tell you whether when a session started and when a session ended. So that's useful if you need to do some auditing. And then auto vacuum induration and hostname, these are also pretty useful depending on your use case. I have a separate talk on this, so I won't go into this too much. But yeah, these are some pretty useful in terms of you as a developer or DBA trying to figure out what is causing, like performance issues with your application. Okay. Now, one thing to note is that these logs are not wall logs. Okay. I think some people might get a little confused with that, so I'm going to go into that real quick. So wall logs. What are wall logs? Wall stands for write ahead log. Okay. And what this is a journaling system. Every modification to a database table is written to the wall log. And at checkpoint time, it gets permanently flushed to the disk. So these wall files, they live in pgdata/pgwall. Now, if you somehow see the word pgxlog, which is what pgwall used to be called, you may want to do yourself a favor and talk to your sysadmin and try to get your database upgraded, because ever since 9.6, we're at 16 now, so yeah, pgxlog is definitely very old. Okay, but yeah, WAL is a journal, and it basically provides a means of disaster recovery. So at a checkpoint, all the WAL files information gets flushed to the disk into pgdata/base. Okay, and then from that point, there's a kind of a, not a transaction ID, but some kind of ID that tells you when the last checkpoint was. And then all the new information gets written to the wall. And then if you crash, you basically say, oh, I know that what's in base matches where the checkpoint is, so I can start with the checkpoint and replay everything. And then you basically recover up to the last write before the database crash. Okay, so you can see why this is a very, very important folder. Now, needless to say, do not delete these files. I say this because our customers have done it before, right? And those customers will remain nameless. But yeah, I think people do get confused. Oh, it's a log file, so I don't need it. But no, it's actually a disaster recovery log file. So you don't want to touch any of those files in there. Now, if you actually go to your PG data folder, here is varlib PostgreSQL 15 main. This is a Ubuntu machine. Okay, you'll see that there's a bunch of stuff here. There's the base folder, which is where all the data actually lives, and then a bunch of other stuff, and then there's the pgwall folder. Okay, so you don't want to touch that file, touch that folder. If you actually go into it, you'll see these files which are very very neatly named with a bunch of zeros. Those are the wall files themselves. Okay, so each wall segment is about 16 megabytes by default. If you compile differently, you might get a different size, but 16 is the standard size. So this is what it looks like. So I'm showing this to you now so that when you ever see it, you know, oh, I better get out of this directory. Okay? All right. Okay. So we talked about configuration, logs, wall logs. I'm going to move on to authentication. This is a really short topic, but I think it's important for you to know. So authentication information is stored in pghba.conf, host-based access control, so HBA. Now, this actually allows you to control in a very, you can slice and dice who gets access and what hosts get access, what database they get access to, how they authenticate, and things like that, whether or not they use SSL. So this is, okay, so any changes to it can just be committed with a hup or a reload. Okay, so here's an example of what a PGHP conf might look like. This is the default, so a real one wouldn't have password. I think you would use some other authentication method. But, so like for example, right, if I say this address is, so basically it's read top down, okay, and then the first match is the first match where your connection fully matches all the parameters is the one that it's going to be using to connect to the database. Okay, so like for example, I type PSQL and I PSQL to my local host. Okay, now all users and all databases are accessible by this one, as long as a password is validated. Okay, so I connect with my laptop to the Postgres that's running on my laptop, and it'll say it's a host. It's not a Unix socket, and then he wants to connect to a database that is on my system, and any user from this one can connect, and then it says okay. And then it will actually send my connection it'll fetch the password information out of the database and compare my password with it. And then if that works, then I can actually log into PSQL and start running queries. Okay, so you can actually limit this by like subnets. Certain subnets can connect to the database. Only certain users can connect to the database. Only certain databases by a particular user, things like that. Okay, so I won't go into too many more examples here, but this is a way for you to control who gets to even try to connect to the database. Okay. All right. Vacuuming. Okay, so I think a lot of our customers that came to us. They came to us with performance issues, and they're wondering why is our database not performing well? And a lot of times it turns out to be they're trying to run a bunch of queries while a vacuum is running. Right? Now, what vacuuming is that it helps prevent bloat. So if you're well, let me continue on. So basically, an update or delete on a table doesn't actually delete or update that particular row that you're trying to edit. It actually flags the row as deleted, and then in an update, it inserts another row. So in that situation, you can actually have a lot of these deleted or dead rows, and then a lot of new rows, and then you're just gonna take up more space on disk, and you're gonna get bloat. And the problem there is that if you need to do like a sequential scan on a table, you're gonna have to scan even past those dead tuples as well, right? So that's why it'll slow down your database. So what Postgres offers is this thing called vacuum, and it basically goes through and flags those deleted rows as reusable for future inserts and updates. So that instead of continuing to tack on more rows at the end of a file, it finds a reusable dead row and inserts there. And if you vacuum enough, you can actually keep your file size to a minimum and just keep reusing rows that are flagged as deleted. Okay. And the nice thing is that we also offer, there's also a feature called auto vacuum, which will periodically wake up, vacuum the table, vacuum the database, and then you don't have to manually do that yourself. So you'll always have dead rows that are flagged as reusable. Okay. Now, but the problem is, a lot of times, the customers, they run in, I mean, we're dealing with like banks and large organizations, and their tables are really, really, really big. And the vacuum takes a very long time. And in those situations, you do see that they're doing maybe like an ETL query, they're trying to aggregate some data, and then it's happening at the same time as the vacuum, and it just creates a situation where the server actually just gets very slow, overloaded with I/O. And usually I recommend just waiting for those vacuums to finish, but in some situations we do kill it, and then we do some stuff to prevent the vacuum from waking up, and then allow their ETL to finish, and then go back and vacuum. Or in some situations, you might discover that the out-of-vacuum vacuum cost delay is set too high. And sometimes you can just set it to 0, and then it'll make the vacuums finish faster, and then you can set it back to what it was before. Okay. So I guess as a non-DBA, if you're running into some kind of performance issue involving a vacuum, you want to double check to make sure out-of-vacuum vacuum cost delay is set lower, or the vacuum cost delay is set lower. Excuse me?
When you do update delete, they flag it as deleted, but why don't they just also flag it as reusable too?
Oh yeah, okay, so the question was, if a delete flags it as deleted, why does it automatically flag it as reusable? And the reason for that is because of multi-version concurrency control, so MPCC. Other sessions might still be able to see that row that you deleted. So in order to handle multiple users, there needs to be a mechanism to be able to flag it as deleted, and those older sessions that are from a different transaction can still see those rows. So you have to wait for all that to finish, and then the vacuum process comes through and marks it as reusable. Okay. Okay. So yeah. So sometimes we kill those vacuums off to be able to let other traffic go through, but that's just like a Band-Aid over the situation. It's a stopgap. It's not the actual solution. You have to wait for the vacuum to finish. So one way to make it finish faster is by changing the cost delays. Okay. All right. Okay. All right. I have about 30 minutes. Okay. So we talked about vacuum maintenance, and we also talked about configuration, things like that. We want to be able to take backups, right? If you have this database and you don't know what the condition is, you want to be able to take backup, be able to restore it. So Postgres, the way that we do backups is using this program called pgdump. And what it does is it does a plain text dump of the database. So when you pgdump your database, what you end up with is just this text file with a bunch of inserts, create tables, whatnot, to create the database. Okay, it's completely human readable. You can pass in some arguments to pgdump to limit which tables or which namespaces get dumped. And then you can actually dump a compressed or binary version if you want to save space. And that actually has an added benefit of allowing you to multi-thread or multi-process a restore. So it's actually, if you can afford to use the binary version, it's actually preferable. The nice thing about pgdump is that it's less likely to copy corruption. Now I'm going to get into that. Actually, I'll get into that right now. Okay. So there's 3 types of corruption. Okay. There's the corruption that happens on disk. So like, let's say, there's a faulty driver, or the head's got some problems. The data on the disk gets corrupted. Okay. There's also corruption that's caused by stray DML commands. So like maybe a coworker deleted the entire table without a or did an update without a where clause, right? Or didn't use the transaction, right? So those corruptions are caused by I guess either humans or bad programs. And then the third type of corruption is corruption by a PostgreSQL bug, which in most users' cases that's not going to happen. I think it's very rare to hit a PostgreSQL bug just using it on our laptops or within like a development environment. Okay, so the PG dump, because it prints out human readable SQL, the disk corruption or the PostgreSQL bug corruption doesn't get pulled into that file. Okay, but it's definitely slower because you're converting binary data into text. Okay, so if you want to take a faster backup, you can use something called PG base backup. And what this does is it takes the entire PG data directory and copies it. And that basically includes all the indexes, all the constraints. It will include all the dead tuples, just everything that's in there. And sometimes you might want that because it's faster, right? But the risk that you run is that you copy the corruption along with it if it is already corrupted. Okay. So my usual recommendation is to have a little bit of both, right? We want to be able to have a plain text dump, and then we also want to be able to dump quickly, like every night you want to do a PG-based backup just in case you need to restore right away. Okay. Let's see. Okay, yeah, so that's oh yeah, the last thing I was going to say, you got to test those backups. We've actually run into situations where people dump their database, they don't test it, and they discover, oh, the dump was empty because they dumped the wrong database, or there was a typo or something like that. So yeah, test your backups, make sure that it works. Okay, question? Okay, good question. So, okay, PG dump will not copy wall logs, but PG base backup will. Okay. When you do the PG base backup, it will copy everything in that PG data folder, but it only copies the wall logs up to that moment, right? So if you want to be able to restore from a later point in time, you're going to want to harvest those wall logs as well, right? So there are other mechanisms that I won't be able to get into in this talk, but there are ways to like constantly pull those wall logs so that way they're always ready for you to use in the future. Okay. All right, that's a good question. Yeah. All right. You guys feel like you're drinking from a fire hydrant? A lot of stuff. I'm going to talk about monitoring real quick. So I guess this is kind of an extension of the logging that I was talking about earlier. And again, I have a logging talk on this, so I won't be able to go too into detail. But if you set logline prefix, by default, I think it was just the timestamp and the process ID, which isn't really useful if you need to do a lot of like correlation between web apps or applications and users and stuff like that. So by using this, every single line will have a timestamp, process ID, I forget what this was, transaction ID, username, database name, application name, and then host IP address or host name. Right? So this, having extra stuff in your logline prefix allows you to find more clues to what might be causing some kind of problem or what might have caused a problem in the past. Okay. And then the other one is log min duration statement. So any query that takes more than this parameter, so this is in milliseconds, so, and like you said it to 1,000, so any query that takes more than 1 second will get printed to the log. So you'll know what query it was that took a long time. So like let's say you have a query that takes, you know, your database every night, you know, if it gets really slow for about an hour and you're wondering why, and you log min duration statement, you see, oh, this query that ran at 3 a.m. to 4 a.m. it took a whole hour, and then you know what query that was, and you can deal with it accordingly. Okay. Let's see. Oh yeah. Okay. All right. So other logging parameters. So log statement will print the query before it starts to execute. So this is different from log min duration statement. Log min duration statement prints the statement and its runtime after it's done. Log statement runs the query, prints the query before it runs. Now, the reason why this might be useful is that if your database crashes, it never finished. So if you have log statement set to print the statement and then it crashes, you'll know which statement actually caused the crash. Right? So this might be useful in some situations. Log min error statement, if let's say you have a app and the person wrote a query and it has some kind of syntax error, and you're wondering, oh, why is this app not working? And you discover after log min error statement that it'll print, oh, syntax error, and then it'll print the query that had the syntax error. Then you'll actually be able to go back to the developer and determine, oh, this is the query that was the problem. You might need to fix that query. Right? So you can set different levels: warning, error, fatal, or panic. Can't go into that too much here, but it's just the severity of the error. So if it was an error like a syntax error, it would just be this. If it was like a query that that caused a crash, then it'll. If you set it to panic, only queries that cause the database to crash will get printed. But if you do warning, then it'll be more verbose. Like all the queries that have both crash and syntax errors, then they will get printed. Log duration will only log the duration, which isn't that useful. I would recommend using pgstat statements if you're trying to figure out just averages of how long a query takes. Log connections, it will show you when the session begins, so that way you can kind of track, oh, this is what this user did when they logged in. Okay. All right. Okay, so we're going to talk a little bit about performance. So explain and explain analyze. Explain is a if you're familiar with Oracle, you might have used explain before. It basically tells you this query will use this particular query plan. Okay, and then explain analyze will actually run the query and show you all the statistics behind some of the joins or sorting or how long things took. Okay. Now there's also this thing called auto explain. As a developer, this is actually very useful. So if you can get auto explain installed onto your database, this is very useful because, especially if you're using an ORM, because ORMs, you specify a lot of objects and how they interact with each other, and then you write to database. You don't know what kind of query gets generated, and in at least a couple instances with some of our customers, we had this query and we're like, this query runs fine. We run it by hand, it runs fine. But then once we run it through the ORM, it doesn't run fine, because the ORM is actually casting certain data types the wrong way, right? So this auto explain will kind of help you definitely uncover those kind of issues. Okay, so just real quick about the difference between explain and explain analyze. So you can see that this is pgbench, which is a benchmarking tool that comes built into Postgres. So I initialized it, and then I'm running this query, select star from pgbench accounts, join branches where AID is less than 100,000. And you can see that, oh, it's going to do 2 sequential scans, and then it's going to do a nested loop to join them together, and then return all the data. Now, you can notice that these costs, it's all that you get. And these costs are basically the estimates that the query planner is using to make the decisions on what kind of scan, what kind of loop, or what kind of join it's going to take. But once you do explain analyze on the same query, you're going to get this additional stuff, which shows you the time it took for each leg, and then the actual time at the end. Okay, so this is actually very useful in terms of finding the bottleneck of a particular query. So usually your query will be a lot more complex than this, and you'll get a lot more rows in this output, and you're gonna find, oh, this is the part that took the most time, and maybe I need like an index on that. So here's, okay. So make sure you use the right data types. Postgres supports a lot of different data types, and using the right one will help you ensure that the query planner is making the best decisions for you. Okay, so don't use all text. I think I've seen some people do that. There's also, you might get confused with JSON-B and JSON. These are both JSON types for Postgres. JSON is just a text representation. It's just basically relabeled, a text data type that just got relabeled as JSON. So if you want to use JSON, use JSON-B. That actually allows some additional features in terms of indexing and searching. You can actually do a lot more. There are some JSON-B operators that make working with JSON a lot faster. Okay, and it's also very important to have the proper indexes on your tables, so that way you can actually do the scans a lot faster. Yeah. Mm-hmm. It will not what? Right. Yeah, it's a dry run. It doesn't actually run the query itself. So if you do explain, delete something, it won't actually delete. But if you do explain, analyze, delete, it will actually delete. So be careful. Okay. All right. Yeah. So just an example here. So I do explain, analyze on this query, and I see, oh, this sequential scan took 45 milliseconds. Now I took I created an index on this column, right? And I run it again, it's a lot faster, right? Because now what it's doing is that instead of searching the entire table for anything where BID equals 1, it just scans through the index, which is just basically just for the purposes of explanation. It's just all the values and then like the locations on disk, right? So if I find all the values in my index where BID equals 1, I know exactly where to grab it from the disk, and it's a lot faster. Okay. All right. My last slide here. So what not to do? Okay, what not to do? Don't delete anything, but also don't kill 9 on any Postgres process. Okay. Even the PSQL process, I would highly recommend against it. Okay, kill 9 on a Postgres process actually simulates. It causes the entire thing to crash, and then it goes into recovery mode. And then once you start it up, it starts up in recovery mode, does a bunch of scans, and then it takes a long time before it's available again. So you'll have a downtime. So don't kill 9. Okay, idle transactions. As a practice, always commit and roll back transactions. Don't leave them open because of that example I showed you earlier. Somebody locks it and then walks away, and then the database is unusable, right? It'll hold up people, and then you look in pgstat activity, look for idle transactions. Don't look for idle. Idle is is normal. If it's not running a query, it's idle. But if it's idle in transaction, that's bad. Okay. And you want to cross-reference that with PG locks to figure out which queries are being held up. Okay? Don't drop anything. Don't delete anything. You don't want to lose it and not be able to get it back, right? So rename things instead. Okay. Indexes, I think you can't just disable them, but yeah, you don't want to drop anything. Just rename things. Okay. And then don't delete stuff from PG data, especially PG wall. Okay. And then if you're curious what commands there are available in PSQL, there's a \h and a \?, and that might be helpful to you. Okay. And finally, where to find help. So there are a lot of different places where you can get help. If you don't have a lot of DBA experience, we have a Slack, we have a mailing list, which is a bit slower to get answers because it's mailing list. There's IRC, there's wikis, docs. The docs are really, really good. I learned most of my DBA experience through the documentation actually. So use the docs, they're really good. And then obligatory plug for EDB support. My company, we offer support for our customers, different tiers. So if you want, you can get support with us. All these links up here are available on the Linktree. So Linktree, Postgres help. So you can use those as a resource. Okay. All right. So that's it in terms of what I wanted to share with you. I hope that you found it very useful, and just want to wish you a happy Pi Day. Okay. All right.
Can you go over wall logs again? So is it just recovery of logs, or is it recovery of the database?
Sorry, recovery?
Of the database, wall logs. Does it just recover the logs within the database, or is it recovering the database itself?
So I think the question is wall logs and recovery. So so when you do a PG-based backup, you get a snapshot of that directory. Now this could be before or after a checkpoint, right? Actually, I think PG-based backup issues a checkpoint for you. So it issues a checkpoint, and then you grab all the files, and then as it's grabbing the files, you could have produced more wall files, right? So at the end of the PG-based backup, you get this snapshot from the moment you press enter. And what you're going to want is all the wall files after you press enter. And then if you actually take those two things, so the PG-based backup and all the wall files, you take it to another machine, you unzip or untar that folder, and that's there, and then you copy the wall files into the PG wall. When you start it up, it'll find it'll start up saying, oh, here was the last checkpoint, and then it'll find all the wall files that got created, or it'll just look for all those. It'll just notice those wall files in that folder. Say, hey, oh, there's wall files here. Let's replay them. Okay, and then it'll play it all the way to the end, and then at that point you can log into the database and then do whatever you need to do in there. Okay, so that's. It's called point-in-time recovery. So if you want to look up the documentation on that, look for PITR or point-in-time recovery, and then you'll definitely get a lot more examples, use cases for that. Okay.
So you said there was 2 different backup commands, and you said the first one was text-based. So, like, what does that look like? Or like, is it like this representation of the entire database in like block by block? I mean, page by page, or?
No, it's text commands. So
Oh,
if
so-
you actually do a PG dump on a database, what you end up with is, well, what it'll be is a bunch of set commands to set the like kind of like environment variables, and then it'll say create table whatever, insert this row into the database,
So
insert into table, stuff like that.
So like
So-
it recreates all the queries.
Yeah, all the queries.
Okay.
Yeah. Mm.
So I have a question regarding like restore. So if you have to restore, do you have to load the schema first before you restore the dump, or the dump will take care of the schema of the database?
Oh, that's a good question. Okay, so a PG dump will dump both the DDL, which is all the table creation stuff like that, and then it'll also have the DML together. If you want, some people do PG dump and say schema only, and then it'll do only the DDL, and then you do PG dump data only, and you'll have a separate file. So, but if you do it all in one and you just pass it into an empty database, it'll create the tables for you, right? But if you want to separate it, you can actually create the tables first, and then load the data in later. So you have options there. I'm sorry?
Does it also preserve the user data, like the passwords and user credentials?
Oh, okay. So those are outside of. So when you do PG dump, you usually pass a database name into it, so you dump only that database. If you want to dump the user information as well, you do PG dump all. Okay, so there's a PG underscore dump all, and then that will dump everything, all databases. And if you only want the global information, I forget if it was there was another flag that you pass in that dumps only the user information. My memory fails me about how the passwords get dumped, but yeah, user information will get dumped too. Yeah. Mhm. Okay. All right. Thank you very much. Testing, testing, testing. We are good.
Hello, folks. Let's welcome Chris Travers, who is talking about nulls in Postgres today.
Thank you very much. Now, before I get started, I'd just like to see a show of hands. How many of you have seen Bruce Momgen's talk on nulls? Anybody? One? Do you feel like you understand nulls after? How many of you feel like you understand nulls? Few of you? Okay. Hopefully there will be no hands that will go up if I ask this at the end. Okay. Put it this way. By the time I'm done here, you will probably understand that you don't understand nulls. So this is why this talk is called Everything You Probably Never Wanted to Know About Nulls. We're going to talk about why nulls are confusing. We're going to talk about where they come from. We're going to talk about what a mathematically based null would look like if we had one and why we don't have one. Or actually, we kind of do have them, but not where we think we do. So, about me, I have been using Postgres for 25 years. I often come to these conferences. There may be one or two people who have more experience with Postgres than I do, but not very many. I have worked as a database administrator, a software developer, a consultant, a engineering manager of database teams. I've even contributed code to Postgres itself, a small little bug fix for a race condition between parallel plan startup and replication. So that's me. I come to these conferences, I like to speak, and I like to push Postgres in directions that nobody else tends to like to push it. So, first of all, we do have mathematically defined nulls in databases in two pieces, but we never call these nulls. There are exactly two mathematical nulls in databases. The first is a null set. A null set is basically, you can think of it as like an empty table, okay? A null set is a set with 0 members, okay? The other mathematically defined null we have is the null tuple. And we're going to come back to this, so the null tuple behaves in ways that defy logic in Postgres, and probably in other databases too. The null tuple is like a row with 0 fields, okay? So we have these two things. We don't call them nulls. We call something else a null, which we didn't pull from mathematics. But if we did use mathematically defined nulls, these are what we would call nulls. However, this guy deserves the credit, or the blame. This is Sir Charles Anthony Hoare. He has called nulls his billion-dollar mistake. Null references he was referring to, because he was one of the major designers of ALGOL languages, right? And in ALGOL, it was a successor to ALGOL 65. One of the things the product people had decided was, we need Fortran compatibility. And they're like, but we have all this type checking. We can't really just make it work with something that doesn't have this in the same way, that doesn't look at data as records in this way. We need to make it work. And so he came up with the idea
of a null reference. Not sure what happened there. Yes, well, evidently, yeah. So at any rate, and then this was designed to make this compatibility just work. Now, if you go and you look up his talk about null references being a billion-dollar mistake, he actually goes into the fact that there would have been some other ways of doing this. But that this was the way that everybody had just kind of settled it, or that this was the way he did it, and then everybody just kind of settled in on it. And he has said that null references have caused at least $1 billion, roughly, of damage since the time they were introduced. Now, we grabbed nulls from these null references. So I think we need to continue this forward. And I think if you look at all the trouble that nulls have caused in databases, it's got to be 10 times what it is in application development. So we ought to be able to add a 0 to Tony Hoare's estimate of the damage of his own invention here. So if you've worked with nulls at all, you know this thing called three-value logic. The basic problem that we have in databases is we've built these things from relational math, but then we have to make them work in the real world, right? So we end up saying, okay, well, relational math works in sets, but we have duplicate entries. How are we going to deal with this? Let's ditch sets and go to bags. We'll define a new entity called bags to deal with this problem. How do we handle missing information? Oh, let's just throw a null reference in there. We didn't have the data, let's throw in a null reference. So we did this. But now the problem is people start to go, okay, well, what does this mean? Well, we don't know what it means, so let's say it means unknown. So we end up with three-valued logic. Null equal anything is null. But because that doesn't work very well, we have the is operator for Booleans, right? So is true, is false, is null. This never returns null, right? So null is true, is false. Null is false, right? If null were fully unknown, that wouldn't work, right? So we've created these other operators because null doesn't really mean unknown. We just sometimes decide that it means unknown. Yes. So one of the things that we all then have to figure out is how to choose the right operator, right? Is not applies to Booleans only. Is distinct from, is not distinct from applies to any data type. If you can figure out why the SQL standards community decided to do that, you're welcome to explain it to me. I haven't been able to figure it out. And then when you have almost anything else, then you have a null in there, it evaluates to null, right? This is relatively straightforward until we get to more advanced nulls. Because unwilling to stop here, we've decided to add more insanity onto things. So, now let's talk about some advanced fun with nulls. So, how many of you think that it's possible to store a value that is null in a field that is designated to be not null? Anybody think they can do this? In fact, it's quite possible to do this. Because, and this starts to get into Postgres internals quite a lot. But I think as we start to understand the problem here, we're going to start to see that null is null is so heavily overloaded that we can get into situations where things really, really, really don't make sense. So here's a good example. Create type foo, and we're going to have two fields in it, an int and a text. Create another table, we'll call it bar. This will have one field, it'll be a foo type, so it's a composite type. And let's say we don't want nulls in there, so we define it to be not null. So now we insert into bar a foo type where both values are null. Postgres will happily do this for you. Now we realize we have a problem, and we do alter table bar add check foo is not null, and we get an error. The check constraint fails because the entry we added is null. How does this work? Anybody, if you have any ideas, just raise your hand. I just want to see a show of hands. Anybody think they have any idea why this would work? Why this would work? Okay, so to understand this, we have to understand how Postgres actually stores nulls in the background. Okay, the Postgres data pages are basically, you have a page header, and then it's basically an onion structure going from the top and the bottom. You have a header going from top to bottom and rows from the bottom to the top, and they meet in the middle, right? In this structure, we want to optimize away the storage of nulls because you can't really use, okay, so let me back up a moment. One of the early approaches to storing nulls is what Oracle does. Anybody here have any experience with Oracle's null handling? Okay, so Oracle had this great idea. We have to deal with nulls somehow. Let's store them as impossible values. Okay, so if we have an integer or a number of any sort, and we need to store it as a null, we will store it as a -0. Okay? Because we don't have any other reason to store a -0, so -0 will be null. Anybody want to guess what a null text string is in Oracle? Nope, yes. Well, it is an empty string. Yes, it's an, so in Oracle, it's a null, it's an empty, yeah, I mean, it'll store it as a, yeah, exactly. So it's just an empty string. So if you do empty string is null in Oracle, you get true. This also leads to fun with concatenation handling and a whole bunch of other things. And Oracle, of course, being Oracle, was the first major relational database on the market. They got to make all of these mistakes, and then, of course, people are depending on this behavior, and they couldn't fix it. Right? They actually kind of fixed it by adding a new data type with different null handling, just so they could kind of encourage people to do nvarchar instead of varchar, right? So a lot of people looked at Oracle's implementation, and they said, that sucks, because it does, right? And so what Postgres does is in the row header, it actually has a bitmap field, which tells you which fields are null, right? And in our example here, is that bitmap field, is that bitmap entry null? No, it's not. The not null constraint on a column, if it's not a check constraint, check is different, but just a not null constraint on the column, all it does is it checks to see whether that bitmap bit would be set. Okay? So an actual, if I were to put null instead of a row type with both fields being null, then it wouldn't insert, right? But when I insert this value, it inserts a new tuple header in the field itself and says, okay, this field isn't null, but all fields within the field are null. Okay? And then what we do is we alter the table, we add a check constraint, and a check constraint evaluates a SQL expression. So because the empty entry evaluates to null, now the check constraint fails. So now you start to see that if you're using composite types anywhere, understanding this becomes really important because there is no way to enforce on the creation of a type that, that a field within that type is not null, right? I actually reported this as a bug back in 8.4, I think. And I was told, can't fix it. Because if you do that, you will break everything that happens with outer joins. Yes, an array of nulls is not null. Arrays behave differently than tuples because... Yes, go ahead. No, you can't. And the other thing is that... No. No, it gets even worse than that because suppose you go, oh wait, but we can create domains and domains can have a not null constraint to them. It doesn't get enforced when you're putting it in this way. And that was what I reported in 8.4, and I was told this, if you try, because the problem there is that if you have a domain that, that can't be null, and you ever query it in a left join, then the return type will still be null, right? So there is no safe place to actually check on type creation that, that the type is actually not null. Go ahead.
If the food type here was not compound, if it was a single value, would you still be able to do this with the row?
So the question was, if the food type was not a composite type, could you still do this with the row? The answer is no, because a row only works for a composite type. So this is the syntax of how you would insert a composite type into an insert. So this is the first beginnings of some of the more advanced problems. One of the other problems that people run into here, and we're going to talk about a few different variations on this, are anti-joins. Anybody here not familiar with the term anti-join? Okay, I will explain it. Oh, sorry, I managed to pull off the thing again. It's not. Don't worry about it. I'm just going to keep going. At any rate, now, this is an anti-join. An anti-join, the simplest form of an anti-join is a not in clause, right? We want to select rows from this table where a join condition to this table is not met, okay? That's what an anti-join is. So the simple thing is to use a not in clause. Now, I just want a show of hands. How many of you understand the problem with a simple select like this with not in, if you have nulls? Only a few of you have probably been bit by this so far. If some val in B has any nulls in it, anywhere, this will return exactly 0 rows. It will return a null set. Why? Because not in will treat null as a unknown, and we don't know if this matches or not. So therefore, it might, and we can't return anything. Okay? So this form is bad. It will bite you, and people usually get bit by this at least once in their database careers. So the minimal fix here is just to do where some val is not null. Go ahead. Okay. Now this works. It fixes the proximal problem. But the problem here is that if you standardize on this format, Sooner or later, you're going to forget that not null is not null, and you're going to go back to the same problem in the first. And the really pernicious part about this is when you test this, you might not have nulls in your data. Later, you might, and then suddenly your query breaks and you don't know why. So this is why this particular fix is bad. Did you have a question? Okay. Yeah. So not exists is a little better, but it has some problems with it. So not exists will basically run this query in what is effectively a lateral join, and then discard cases where the lateral join condition is met, right? The problem with not exists is a little bit more abstract. Not exists is a perfect general tool, but that subquery could be anything, right? And as a result, there is very little that you can do to make sure that the planner can effectively choose the best plan in this case, right? If you're just doing an anti-join, not exists is difficult for the planner to deal with. I have very rarely seen not exists perform anywhere near as well as I thought it should. So, so not exists is better. It's going to get you out of this trap, but it's going to create a whole bunch of performance problems in the meantime. Go ahead. So the problem here is, again, this gets treated as a lateral join and a discard, right? So whatever is evaluated in that loop, it's hard sometimes for the planner to compose it into the plan, okay? Yes, I have found not exist to usually perform, at least on Postgres, slower than not in, but there's a faster version that I'll get to in a moment. Okay? The best approach, sorry, it got rid of the dot, A dot star, so that should be select A dot star from A, left join B using some val where B is null. This one I usually find performs way better than not is, and it even performs usually better than not in. No, sorry, not exists, and it usually performs better than not in. And the reason is that that the left join side is much better optimized, and consequently, it tends to be a lot easier to compose this on the planner side. It's a little bit more. It's a little bit more, how should I put it, verbose. And it's also a little bit more limited. In other words, this only works on anti-joins. You can't do some of the more complex logic you could do with not exists, right? But because it's more limited, the planner can make some better assumptions. So my general recommendation actually is to write anti-joins as left joins where the left side tuple is null. And then it will simply do the left join and it will discard it anywhere that join condition is met. And it will do it as a left join rather than as a lateral join. So, so this is sort of the initial piece here. I have a few more examples that I'd like to get to if we don't have questions. Are there questions at this point, or should I just kind of continue to a few more unexpected pieces? Okay. At this point, I think I'm going to pull up a let's see, this is probably too small for everybody to see here. So let's see, it's Control Shift. Let's do this. Okay, so since many of you have not seen Bruce's talk, anybody, I just want to see a show of hands. How many of you think select row parentheses is null will return true? Show of hands. How many people think it'll return false? Show of hands. False people have it. Let's see. Oh, it returned true. How many people here think this will return true? Nobody? How many people think it will return false? It returns true also. The null tuple is both null and not null. This is Schrodinger's tuple. And if you understand the rules by how null tuples or is null gets evaluated with a row type, then this actually kind of makes sense. But it also really doesn't, and it's a really good example of the lack of logic behind nulls per se. So, so the basic thing is if I put a comma in here, right? So now I have a tuple with 2 entries, right? Now we get what? So why didn't? Yeah, I think I'm going to just create a type here. Wait. Oh, yeah. As. Just do foo2. It probably is just, I can probably do this. Why is this? Okay, so I'm not sure why it's not accepting the comma in here. Oh, you're probably right. No, oh yeah. Okay, let's, yeah, I'm just going to create a type foo2. I should probably clear these up between talks. So as we have foo3 now. And for some reason, this has worked in the past. I'm really not sure what I'm doing wrong, but maybe they finally fixed the bug that you reported. I don't think so, because so if I just do select this, I still get the same problem. If I still do this, I still get the same problem. Just a second. Yeah, it should be row. I'm probably missing something really silly here. Probably mistyping something or so forth. But the general rule is that a row type is null if and only if all fields are null, right? What if you explicitly type null, null? Oh, you're right. Yeah, there we go. See? So this is now null. And this is now not, and this is not null, right? So in the case where we have, a null row, right? If every field is null, then it is null. if any field is not null, then it is, what? Yes, but it shouldn't be reporting false on both of these. Should be foo3. See, what I'm noting here is that for some reason it is casting, it is returning. I know what the problem probably is. Nope. So I'm not entirely sure why this is one of the things which I find about nulls is I sometimes get blindsided by behavior. The rule is supposed to be, as I understood it, that if you have any non-null field, then the row type is not null. But here we're seeing that it is neither null nor not null. Yes. And now it seems to behave as we expected before. So now what we're seeing here is that there are values which are neither null nor not null. And there are values where if every field is not null, then it is not null, right? So now what you find is that if you have a tuple which has 0 fields in it, then it is true that that every field is null, and it is also true that every field is not null. Yes, so it is null and it is not null. But if we have a field which is, but if we have a field where, if we have a row type where one piece is null, it seems to evaluate not only to it is not null, it is also not null. Yes. Yes, exactly. Yes. So this is actually a really good example of why I usually test almost every weird case of nulls before I demonstrate them, and I seem to have missed one of them today, and I actually learned something up here while I was. But this is also a really good example of how these rules often don't make sense. So let's see. I had, so this is actually interesting because if you look at a row where you have both of these as null, right? Then it is null. But if we do this, an array of nulls is not null. Again, there's no consistency, and the reason why there's no consistency is all null actually means normally is no data here. Okay, it is just a null reference. And then when we started to say, okay, let's determine whether something is null or not null, now we have made a mess of things which we are never ever going to be able to get out of. Yes. Well, if we do an array with this, it will still be false. An array which, even if I have a zero form array is also not null. No, wait. So a zero member array is also not null. Arrays are only null if they are explicitly null. Any other value is not null. Row types have extremely inconsistent logic and lead you to cases where things may be not null and may also be null, in other cases where they may be not null and at the same time not is null. So this is these are pieces which really kind of highlight some of the difficulties. Again, one of the really cool things you can do here is you can actually leverage this when you're doing anti-joins, like I mentioned before. You can say we only want those cases where we actually have a match on the row. But now I'm starting to wonder about that because even though I use that all the time, this row handling is weird and it's not what I expected, so I'm going to actually have to go back and double check, so to speak. However, just a second, I want to see something here. If I do this, so that is still, okay. Yeah, so so I'm going to just check this also. Maybe it may be about casting. Nope, I'm stumped by this. This is this was not expected for me. So we've kind of talked about like how nulls are stored and some of these things. We've talked about the three-valued logic. We've talked about the history and the fact that these are null references, that they don't actually necessarily mean anything. Are there any questions on this side at this point? I know I'm quite a bit early. I'm trying to think if there are any other interesting examples that I can go over. Yeah. What?
I have a question. When did you actually use an array type and a collection type? When is it useful? Besides, why can't you just create more columns in a table?
So, so what I usually suggest here is thinking, so arrays are useful in one of two specific kinds of cases, okay? The first case is, it may be useful to represent a single value as a series of sort of sub-values. So as a completely contrived example, and then I'll give a more specific example. It's a completely contrived example. You could break down an IPv4 address into 4 octets, and so you could store that as a 4-member array, right? That sort of thing can be very helpful if you needed to do processing on one piece of it. Like if you want to, figure out whether something here has one of those members being a particular value. A real-world case I would give on this would be when I worked on a big life sciences database. We would generate something called blast reports, and I'll just give you an example of what a blast report is. Blast is, I forget what it stood for. I think it was like basic lateral alignment search tool, I think is what it stood for, right? And the idea is that you have protein sequences, right? Or genetic sequences, and you're looking for similar sections in different ones, and there may be offsets and things like that. And so what we would do is we would run the tool that would do these searches, and then we would store like the top 10 results in an array. We could have stored it in a more normalized form, but the problem with doing that is that with the size of the data that we were dealing with, storing it in an array just simply made performance a lot better. Because it's made performance a lot better because instead of finding rows that might be on different pages, you'd get the whole row set once out of a single page. And so that helped a lot in that case. Over time, yeah. So in this particular case, we didn't index the individual entries. If you wanted to do that, that would be possible, but it would be a lot more difficult. You'd have to probably write a function to extract what you wanted to index out of each entry, turn that into another array, and then you would probably have to take that and generate a gin index on that, on the output of that function. So it's possible, but it's, we were, in this case, only looking up the blast reports by ID, and then we were dealing with deletion anomalies by doing a further expansion and join out of that to remove things that had been previously deleted.
I actually had a real-world use case where I used it in many places, especially to create like tags. For example, in an e-commerce site, each product had a bunch of different tags. Let's say for a candles e-commerce website. So it was red, small, 6x4, a bunch of different tags and attributes. And that allowed to write a query that was very efficient to find now all the items that have the tags, let's say, red and small, red and votive. So, because it is indexable.
Yes.
So it was very effective, very efficient. Also in blog posts, when you many times put tags on them. So filtering, when you want to filter the result set according to attributes. Because
yeah. So.
Oh, but because you know it's 4, but if it's tags, you don't know how many tags you'll have.
No, I mean, but like with, okay, so with the IP example, in actual practice, it probably doesn't make that much of a difference. But one thing that it would make is that if you were to create, for example, a domain that said that we have 4 entries here, right? Then you could create functions on the domain that could present it as an IP address that could perhaps do other things to it, right? If you store it in columns, there are ways to do this with inheritance. They're ugly, but you could still attach functions to the record type to preserve it, to present it however you'd like, right? I wouldn't recommend doing it that way because Postgres has an IP tables type, no, an IP type. But as I say, that's a contrived example. So again, if you have something that's structured and you need to present it as substructured, that's a good option. Another thing to keep in mind is that SQL arrays are not like programming arrays in one really important respect. And that is that SQL arrays are strictly rectangular, right? So if you have a 2-dimensional array in SQL, it is not like an array in choose your favorite programming language. I think, I'm not sure, I think Fortran arrays may be comparable. but I can't think of any other language where arrays are comparable. And what this means is if you have a 2-dimensional array, you can't have the first ordinal being 4 elements and the second ordinal being 3. Everyone has to have the same number, right? And what this means is that arrays are actually matrices. So if there's any data you want to store as a matrix, okay, or you want to model as a matrix, an array is actually a really good data type for that. An example that I would give that I pushed for in a previous place I worked was that we would get financial risk matrices from an upstream provider. And that would have been a perfect example to use a SQL array to store, just simply because the data type matches what you're getting, and there isn't really a normalization you can do to it, right?
Can you give an example of the data right now?
So it would just typically be like a set of, it'd be strictly rectangular, usually a set of, usually like maybe, I want to say 5 by 5. Yeah. And I think if I remember right, they would be all floating points. So it'd be like 0.2, 0.34, 0. You know, such and such. And then this would allow you to look at like severity and over time of a particular kind of incident and how it was likely to affect certain kinds of markets, right? And I don't really remember where we got these from, but just because the data was like a matrix and then it was processed as a matrix, it would make perfect sense to store that as a SQL array.
So those looked at as a whole.
Yeah,
as a portion.
exactly.
Also nowadays you can use JSON-B. When I use arrays, it wasn't.
But yeah, but JSON-B arrays are not like SQL arrays.
Right, so it allows me to do what I needed to do.
Yeah.
I could have done now with JSON-B at the time it wasn't available.
Right. So the thing is, like, JSON-B arrays are JavaScript arrays, right? They can be completely heterogeneous. They are one-dimensional. And if you want to have two-dimensionality into them, then what you do is you basically have elements which are also arrays, right? So what this means is you can have a JSON-B array that's object, object array, object array, object, object value. So that's something where it looks more like our tuple types or record types but you can't store a record type without any other type information in Postgres, right? Because if you try to do that, then there's nowhere to decode the record header from. So I would definitely say JSON-B arrays are also useful. They're relatively different from, they're completely different from use cases wise from SQL array. I would say if you're storing actual array data, then I would definitely use a JSON-B. If you're wondering where I would probably do that, if I'm building, for example, a large log management system, then that data that's coming in may be relatively unstructured, and consequently, putting it in a JSON-B object makes perfect sense. Yeah, the question is about compression on it, and yes, compression would help also. Although, interestingly enough, when I was working in a previous place, the compression on JSON-B we could get on a column wasn't anywhere near what we could get on disk if we put it on a compressed file system. So since this was almost exclusively an append-only workload, we just put everything on ZFS, compressed it, and that way we could ingest faster data just simply because we could trade CPU cycles for IOPS. JSON-B. Yes.
The situation. Actually, okay, if you want, I can show you. I have the ways of converting JSON to like relational normalize and back because there is one function which converts record set to JSON and back, and most times, all the time, I hear customers are saying that they need JSON because they do not know what type of data they receive. It usually overrated. In real life, they know what they receive, at least like some things, and it's more faster and more economical to convert them when you receive it from application to relational, and then convert it on the outer. Again, if you're interested, I will show you, because I have it. No, I can convince your developers. Just ask me. I can convince everybody, right, Omar? Right?
Yeah.
I'm just a moderator.
Yeah, so the question was between choosing JSON-B and plain JSON. This is a slightly different topic, but there are actually several cases where I've seen things that are supported in JSON that are not supported in JSON-B. And if you're hitting those cases and you don't need the GIN indexing, then it makes sense to use JSON instead of JSON-B. I'll give you just the 2 top examples that I have off the top of my head. JSON as a specification allows duplicate keys. In case you're happening to use duplicate keys, JSON-B will not work for you.
And having said that, you should not have duplicate keys.
You probably should not have duplicate keys. If you are using duplicate keys for something where you actually need duplicate keys, then sure. But there's probably better ways of doing it than that. The second one is actually a really interesting issue with the internals of how things are stored. JSON, the specification, allows you to do Unicode escapes inside of JSON identifiers and strings. JSON-B, when you store it, stores actual strings. So if you have embedded null characters, which might happen, for example, if you're actually like trying to store actual binary data, then JSON-B will not work for you. Yes. So if you do a Unicode U0, you will get an error. I can probably. I'm trying to remember how this works. I'm trying to remember if this is right. Wait, I don't think that's right. So I think that's the wrong. So let me try this again. Select. Might be. All right. Okay, so we have this. This will throw an error. So yes, do not ask me how I happen to know this. Yeah, I mean, the only way anybody knows this is by stepping on it, right? Unless you just happen to be at this talk and you're going, huh, that's really interesting, I'm going to remember that. So the fundamental problem here is that the way strings are stored in Postgres internally in memory is as null terminated strings. And so what happens here, if it were to try to convert it, is that you would end up with possibly a null termination character inside the middle of your string. And this then causes a problem, and so the safety is there to keep that from happening. There isn't a way of really handling it unless you want to redesign your JSON documents to, for example, store things in base64 encoding or something. But that's generally speaking not the best way forward. So So those are the two cases where JSON works and JSONB doesn't. I think there is probably a solution. If you want to hear my solution, you will not like it. You can probably guess what it is, and it will not work on fully managed Postgres instance services, but your only other option is figure out how you actually want to represent this on disk and in memory, and write your own type. Which, the code is mostly there for you in Postgres. You can copy, paste, and modify. So, but most people aren't going to want to do that. So. Can I try the same thing but cast it as text? Yes, because this is a specific aspect in how JSON is supposed to encode Unicode characters. So, yeah, so that's a bit of a digression. But are there any other questions on the null side at this point? I guess not. Yeah, so if you're using composite types, one more time, if you're using composite types, you want to make sure that you don't have a null type, then you put is, no, you put a check is not null, you don't just rely on the not null in the, on the column definition. That's how you have to handle that, yes. All right.
All right, so Chris promised that everybody's going to be stumped by nulls by the end of the talk. I think he kept his promise. Thank you, Chris.
Yeah, works well, even I'm stumped.
Everybody in the room, including Chris.
Yeah, I did better than I expected.
Hello? Able to, are you able to hear? Okay, okay. Cool.
Hello, folks. Up for our next talk, Postgres memory internals, well, memory management internals. Please welcome Krishna Kumar.
Hello, everybody. Welcome to Postgres Memory Management Internals. I am Krishna Kumar. You guys, all of you can call me KK. I'll start off with a bit of introduction about myself and how this talk has come about, primarily. So I'm engineering manager for Postgres open source contributors and committers team in Microsoft. I started roughly like 22 years back born into Linux and was doing embedded system porting on things like MIPS and SH4 boards. I don't know how many of you probably are aware of those boards, but I know that SH4 support got taken away from Postgres sometime back, so that's when all this was going on. From there, I joined HP, worked in high-performance computing for a while, scalable file systems, did join a startup of hybrid cloud storage, and it got acquired by Microsoft. That's how I landed in Microsoft, continued doing storage stuff, slowly moved into Kubernetes side of things for some time, did a lot of open source work around authentication, storage, and things like that on Kubernetes side. In the last 3 to 4 years, I was part of the team which built the managed cloud service called Azure Flexible Server in Azure. So we have a managed offering which I helped build. Recently, roughly like last year, middle, I joined as the engineering manager for contributors and committers team. The most exciting part of my job is the people I interact with. And these are the folks who have commit privileges to Postgres, who contribute a lot of code like Thomas Monroe, David Rowley, Daniel Gustafson, Anders Freund, Melanie, Bilal, and Melly. So all of these folks I interact on a day-to-day basis as part of my job. So a lot of things I get to learn via them, and this is my attempt to share those learnings with all of you. And as much as this is a sharing session, I would like to learn from all of you as well. So continuing on. This is roughly how the talk is structured. We'll quickly touch upon the architecture just in the memory, like context of memory. We'll talk about how Postgres uses the shared aspect of the memory, how between processes it uses those. Then go into a little bit details of the types of shared memory that's around in Postgres. Then we'll talk a bit about the local aspects of it, how Postgres, even though really it's written in C, it still offers a sort of library which kind of gives a managed, like language feeling when you write code in Postgres. We'll talk a bit about the kernel interactions that Postgres has. We won't dig deep, but still we'll go through some of those aspects. Then we'll talk a bit about how to debug some of these issues in terms of not bringing many issues into the picture, but just enabling all of you to be aware of these tools and how to use them and things like that. We'll touch upon configs which matter, and it's not like a comprehensive thing again. It's more like how can we, like what are the interconnected pieces here with memory and the configurations. Then we'll talk about projects. Some of this are currently out there in the mailing list. Some of this have patches out there. Some of them don't have, and some of them is close to my heart, so I just want to talk about it so that there's more people, if they want to join and collaborate, would like to engage. And then as anything else in the open source world, nothing stands on its own. There's a village behind all of these things. These are learnings from a lot of people. Just want to say thanks at the end to all of them as well. So we'll start off with the usual quote, which is obligatory to put in. that for a long, long time, the promise that Postgres at some point will become threading, like will be based on threading, but at this point in time, Postgres is still process-based. There's a lot of momentum, at least around the last year. We have started seeing more focus on making this happen, but it's not really happening for a long time, since 1990 promises at least. So at the end of the day, Postgres is a process-based architecture. Postmaster spins up the rest of the processes, and everything out there is dealt as process. So when new connections come in, there are more processes getting created, and there are like some default ones. A few of them I picked and put it here. So the lot of memory management aspects of Postgres is based on this architectural fundamental, right? Like if we had process, if we had threads, some of them is not needed. Since we have process, some of them is designed a certain way. So that's how this context is important. We'll talk about, in this talk, we'll talk, the structure of this talk is like, we'll talk about the shared memory aspects of it, the shared process, different processes sharing the same memory. We'll talk about local memory aspects and the kernel memory aspects of it. So just in terms of, this is just a PMAP output from one of the Postgres processes, just to give you a glimpse into how these shared memory and, like shared memory and local memory appears. So in this case, like the shared memory, we can think of shared memory as static in the sense that this is not the typical static memory I'm talking about. The static here means that when the startup happens, you already, like allocated this memory, and then you continue to use it in between the processes. And the dynamic side of things is when after you have a certain execution going on, let's say you had a query which Postgres wants to make parallel. At that point, it needs to generate new processes and then have new shared memory attached to it. So that's the concept of when I'm talking static and dynamic. I just gave it a name. It's not the typical C static dynamic thing, but just so that we are aware. In shared memory, so here, the picture that is there, I'll go into details of this later, but just to give you a sense, if you run PMAP, here's how you will typically see this. One of them is static type, which is declared in the beginning, and the other one is like, as we go through, we'll attach as needed. So in the static memory side of things, we will talk about how it's created. That is when the startup happens, how it's created and things like that. We'll talk a bit about how locking is done in this framework, because as you can imagine, the locking will be totally different if we were to do threading. So just want to touch upon that aspect of it, like how locking is done in Postgres within the internals of Postgres. We'll go through some examples. Primarily, we'll go dig a bit on what buffer pool is and how it's managed and things like that, and what could potentially be the enhancements that we could make in that area. We'll quickly, briefly look at like SLRU and wall buffers, but primarily we'll dig more into the buffer pool side of things. So at some point in time, Postgres used to be System 5 memory, shared memory mapping, like that's what it used to use. Over course of time, we have gotten to a point that there's a little bit of memory that we use with System 5 memory for making sure that there's no two processes which are running at the same time, or two startups which are happening. But outside that, everything has become more and more of mmap stuff and anonymous allocations. So as you can see in this address space, the mmapped shared memory that we have, which is like typically if you take a file and then memory map, that's what generally you do. But in this case, we don't have a backed one. We have anonymous memory that we map. We mmap this area, give the shared flag, attaches to the primary process, right, the postmaster. So from here on, anytime there is someone, some process which forks, it also gets this address space with it, which means that it will get access to the shared memory, and then from then on, it gets, gets to use these areas. So that's the way in which the shared memory is created, and that's the way in which fork happens. You have multiple choices. If you want, you can go back, but typically this mmap system is what default comes, and most of the times we end up using this. I just want to touch upon a bit here. Typical allocations you can do with regular memory, but if you have huge TLB and huge pages enabled in your system, you can use those flags. I'll talk about the configuration in a bit, but you can use those to make sure that this memory is allocated in the huge pages as well. So that's the creation part and how the child processes and rest of them get it. Like as promised, we'll look at locking a bit. So because this is shared area, there's a lot of back and forth that happens between these processes. And locking, as you can imagine, is one of those things that we really need to happen when we are coding in this space. So just to give the context, this is not the row locking or a transaction locking that I'm talking about. I'm just talking about the lightweight locking, which you use when you're coding inside an extension or inside Postgres. So lightweight locks are implemented in a very straightforward fashion, although as you get into the nitty-gritty, it becomes complicated. But the way that this happens is, first, there is atomic operations that's possible on the memory. So you use that to lock the memory. If attempt fails, then you get into what is shown in this picture, the slope path, wherein you first, the process first puts itself into a queue, then it tries to lock again. If it doesn't work, it will wait. And in Postgres, currently, we use semaphores to kind of like make sure that all of them are waiting on the semaphore. And when unlock happens, we go and like wake the rest of them up to see if they can lock again. Currently, we use semaphores, but there are proposals around whether we could use the more modern stuff like futexes and stuff like that. So one thing that I missed mentioning was that the whole talk is about how Postgres is done on Linux, not on other operating systems. So that's why I'm using futex and other things, just so that you have the setting. But one possibility is that instead of using semaphores, can we use something like futex? Semaphores itself in Linux is implemented on top of the futex system calls nowadays. So there is, trade-offs around that. But in general, the process is, it depends on the atomic locking, and it depends on the semaphore as well. And there is a wake-up process that it goes through in locking. So this is how the locks are designed, and this is what gets used when Postgres processes have to communicate between each other. A bit of detail around this, that like it doesn't have sophisticated things like deadlock detection and things like that. So when you are dealing with this, please be aware of those things so that as a programmer, you have to deal with those things. There is shared and exclusive mode in this locking available. And typically in literature, the latch is what folks use, but I'm just calling it lock because of the name of the functions. And a lot of this is like in the short-lived situation, like I was saying, a lightweight locking scenario. So that's about, so we covered the shared memory aspect of it, how it's created. Now we talked about locking a bit. We'll go into one of the examples that is front and center of a lot of usage of this. Postgres, as you can imagine, needs to be performant. So anything we access from the disk, we want to be able to cache it. Also, we don't want to operate, we want to make sure that we operate more efficiently, which means we have something called buffer pool in Postgres. And this buffer pool is implemented on top of the shared memory that is there and statically declared one. And here, the entire buffer pool allocation is done into blocks of various, blocks of sizes. And then there is like descriptors which are defined on top of it, which is just like metadata for each of these blocks. A lot of times, this particular buffer pool that we have in Postgres is optimized to get to a place where we have the most recently used like page, as well as the most frequently used page itself. So it's a give and take kind of scenario where we have to balance these things out. But at the end of the day, currently Postgres uses a very, let's say it was somewhere, I think in the 1960s or so, the page replacement algorithm that's there. I'll give a brief about that. Like effectively, we do something called a cloak sweep, where every time we need to evict a page from this buffer, we go around through the buffer. So the ring buffer actually doesn't exist, but based on the descriptors, we go through this buffer. And then we keep reducing the usage of this, like each of these block buffers. If it gets to 0, then we can evict it, because recently nobody has come and updated it. So that's kind of the basic logic that we have. And there are a bunch of discussions around this on whether we can improve this part of it. But right now, we still are using the clock sweep algorithm. One challenge with this is that in Postgres, there is a lot of activities which could actually trash the entire buffer. Like vacuum and sequential scan is two set of such things, where if we start doing the sequential scan, we could actually just fill it up the entire buffer pool and trash the regular rest of the I/O patterns that were there. So in that context, we use something called buffer strategy control, wherein fix a set of blocks from this buffer blocks that are there are the only ones that we can touch. So which means that when vacuum comes up and tries to do some of these reads, we do this buffer strategy. So it doesn't go and uncontrollably trash the entire buffer pool. It gets a fixed size that it can operate on. So that is how we tend to make, Postgres tends to make the scanning, Postgres tends to make the scan resistance in this buffer pool. But at some point in time, a sophisticated algorithm, probably something like CAR, which has built-in scan resistance, could help here as well. But overall, the theme to take away is that the shared memory that we have here is used for buffering the contents from the disk. And we do have a page replacement and clock sweep algorithm built into this. So just to give a, like a picture here, this is the buffer full content, how it looks like. So one thing that I didn't quite touch upon was there's this buffer hash table. So whenever we have a need for the buffer, we need to we need an easy way to look up the buffer. So if you look at the buffer pool, the rel file node and like these IDs, right? The 5 IDs after buffer ID, those are the ones which are used to map in that buffer hash table. Because of that, we have a very fast lookup mechanism as well. We use this 5 tuples, look up the table, and then figure out the blocks from which we access. In general, in the operations that we deal with, and that's an optimization we have as well. The rest of it is all like, this is from a table which I recently populated. So as you can see, there are fields which says whether this buffer block is dirty, the buffer IDs of this, and a bunch of these other values that are required to maintain the buffer pool. The other parts of this is, there are many of the things which use this shared memory, wall buffer being one of them. SLRU is another thing, which again uses a page replacement algorithm, and there's a lot of discussion which has happened in the past on whether the SLRUs can go into the buffer pool itself, because they kind of solve the same problem but in a different way. Can we enhance that to focus on one algorithm or usage is another thing. So just laying out, these are the other SLRUs which are there, which we use in the shared memory as well. Before I move on to the dynamic part of it, any questions folks have? Yes?
So that portion earlier about the use of mmap
Yep.
is interesting. I was wondering if you have any insight on how that works on Windows where you don't have format.
Unfortunately, I don't know. So, yep. But I will get back to you because I know someone who really knows this. Yeah, Thomas Monroe knows. Thomas Monroe, like he knows it. I mean, like it's not like he's working on that, but he knows all of these details. So, one? Okay, yeah.
In the previous slide, when we did select those from this, for example, 3D stats, is that available always, or is that part of an extension?
I don't know that part, but I was just using like within the user session. Like I didn't.
Without installing extension?
No. This is stat. This is no extension. Sorry. Yeah, I do know that. It wasn't. Just that this is available. I don't know which version is available. I was just using the head of the tree, but yeah. Cool. So let's move on to the dynamic shared memory part of things. So there are scenarios which we really need dynamic shared memory, like parallel query execution being one of them, where we have not allocated the memory in the beginning, so we can't use the fork magic that we rely on. We need some way in which we newly allocate this memory, then attach it to the processes that are there. So the way in which, so there are two types of dynamic shared memory that is available. As the name suggests, there's DSM and DSA. So dynamic shared memory, like DSM was the one that first came. And then DSA was built on top of that for more sophisticated operations. Like if you want multiple DSM segments and want to manage the allocation better, things like that is where DSA came into picture. In DSM scenario, like if you look at the right side of the slide, this is how the operations really happen. We take a file, give it like an ID at the end, like inside dev SHM. Then we mmap that into the system, and then pass this ID to the worker processes or the next set of processes which spin in. So they can then attach this to their own address space as well. So the secret sauce here is really that shared memory attach and making that happen. Here I'm showing you something which is not recommended when you deal with things, but just enabling parallel query by default and just running a select thing so that it spins off some workers, just an example. So as you can see, it opens it, then mmaps it, and later when the query is over, it unmaps it and then unlinks it. So this particular shared memory file is what gets mmapped, so the processes will get with each other. One of the salient problems that is there with this is that when you do this dynamic shared memory, the process mapping, like in terms of address, will be different in different processes. Previously, we could have relied on that, but here we need to actually make mechanisms to make sure that we have a different way in which we can map and figure out where the memory was. So in both DSA and DSM, this kind of works out fine, but DSA has more like friendly usage of segments and things like that. And it was developed, both of them, like the original one, I believe, was developed when we were starting to get to parallel queries. And parallel hash joins, when we got to it, that's when DSA was developed as well. So that's the way in which dynamic shared memory is dealt with. So we crossed over the shared memory, the static and the dynamic part of it, went through an example. Now we'll talk about how local memory is operating. Local memory is like, think of it as malloc when you do in a typical application, where you need objects to be allocated in the memory to make things happen. And that is where it's used. So Postgres offers this, I would say, infrastructure where there's something called memory context. And memory context has various APIs, right? Like alloc, realloc, reset, delete, all of these APIs. And it is sort of an interface kind of model where there is memory context and then you have implementations of this. So a typical implementation of this is alloc set, which is what is used in most cases. Then there are like specific implementations which folks have developed over the course of time to improve the memory management part of it. SLAB is one of them where we had to do like a large equally, when we are doing a large equally sized objects, SLAB is what we should be using. And I believe in logical replication, we had used it significantly in the past. The one important aspect which comes in very handy is that there is something called current memory context, which always will point to your current context that is there. And I'll explain in the next slide why that becomes important. So this is how the memory context itself is built with a hierarchy in mind. So the right side shows the top memory context, which is what we start with. In every process that we build, we have top memory context, and then from there we have a child memory context from there, and so on and so forth. We can go to levels, multiple levels of this. So at any point in code, so we don't have to pass the memory context as separate function parameters and things like that. It's all there declared so that whenever you are in a particular function and then you want to look up what's the current memory context, you always have, like I was saying, the current memory context. All of them is hierarchically tried in the way that when you get to from a parent, you can get to the children that have been allocated. The way that this comes in handy is that you don't have to manage the memory, that if you had an error, you need to come back and free this up. Like you just can free up the parent context at wherever you are, and the children will get freed as well. So this is already available within Postgres, so you don't, Postgres core code, so you don't have to think about memory management a lot of times. And the malloc portions of this, the internals of how the memory is managed, and whether we should free it up, all of that is handled within the memory context, so we don't have to really do this. We can call the free thing, but the implementation will determine what's needed. Want to touch upon a bit on how exceptions are handled. Exception is not really exception handling in other languages kind of exception, but I'm talking about if we had an error at a particular location, we use this set jump kind of mechanism where if it goes back into the stack at a certain point, it still will free up the memory, because we would put hooks there which make sure that the set jump, the capture of that, the handler of that will make sure that we free up the memory there as well. The last point was what I mentioned earlier. The last point is another technique which we use where when we start allocating, if we start allocating the contents of this, like the memory context of this, until we get to a point where we can move forward, we don't assign it to the parent process. What that means is that, parent context. What that means is that we can handle the errors very easily. If you have an error, we can just free up the entire block instead of trying to free up one piece by piece. And at the end, when we are safe and steady, we can do a setting of parent context as well. So that's how this is managed. Yeah, so that's the local memory context part of it. Before we move on to the kernel side questions. Anyone? Cool. Yes. Okay.
But if you test things, oftentimes if you accidentally use the row context, the memory might still be accidentally valid.
Got it.
So if you're writing these things in C, do you have any recommendations about using, say, enable C asserts or other compile time flags to make your test environments more likely to catch your problems?
So the test environment, there is a option to enable asserts by default, right? Like, and then, like for example, when I change code, I enable them by default, and then when you test them, these things like get caught up. But like, as if someone has put the assert there, that's when you would get it. So it's a little bit like context specific that we'll have to look at this case and then see it. But there is an option to enable this, like while compiling the. Nowadays, Meson is what we all use. So while configuring, we can set it and then run it that way. Cool. So because we have processes, as is the case with anything in Linux, there is some amount of memory consumption that every process takes, something like the page tables, there's some memory for stack, and things like that. But I'd like to talk about this concept of double buffering that typically happens in the Postgres world currently. So when we talked about the buffer pool, the idea was that we would have a cache for every content that was there that we deal with from storage. But most of the times, Postgres is on top of file system. So at that point in time, when we are reading from storage, like reading a file, for example, it also gets cached in the kernel page cache. And this is one of those things where we potentially could have the same copy in memory inside Postgres as well as inside kernel, right? Like page cache inside kernel and buffer pool inside Postgres as well. So that, it's sometimes very useful, sometimes not very useful. But I just wanted to bring that topic here so that I can show some of these ways of debugging this. So basically, FinCore is one of those tools that you can use to figure out the contents from the buffer pool. In this example, I'm looking at a table called my large table, and then I filled it up with some large amount of data recently written, and then looked up the FinCore to look through the buffer cache and page cache of the kernel, and then as you can see, the number of the so when we eventually look at the file system layout, the OID of this will be what will be there in the file system. So that one, when we look at the file node relation, we can find that the pages are cached appropriately inside the page caches. Now, of late, at least few years since we have been working on this thing about making Postgres to go to a place where we have asynchronous and direct I/O built in. Both are things that we really need eventually for better performing, better performing Postgres. A lot of the group in Microsoft, we work on that, like Anders, Thomas, Melanie, for example, work on it, and David too. So when that direct I/O comes, what you will start to see is that this page caching is not like the pages in the cache that is shown on the right from the kernel will no longer be there as well. I was planning to show a screenshot of that, but didn't get a chance to put it in. But right now in Postgres 16, you can enable direct IO in debug mode. Then you will start to see that we no longer cache it inside the kernel. There are performance aspects of this. It cannot be used directly. And that's the part where the development phases of Postgres is taking us through some project milestones where we'll get to a place where we have asynchronous IO and DIO built in, and then we will solve some of these performance challenges with buffer pool as well. So, yeah, so that kind of concludes the type of memory. We talked about shared, we talked about private and like local, and we talked about kernel memory consumption. We will talk a bit about configuration. A lot of talks here already covers a lot of this, so I'm not going to be comprehensive around this. Just touching upon some things which really are interesting and curious when it comes to memory management. So shared buffers is the first thing. It will determine the buffer pool aspect of it. Make it big, then you might actually consume memory in a way that a kernel itself won't have memory to do stuff for its page caching. So there needs to be a balance in that. That's the one thing to remember. But some tweaking here could help as well in a lot of scenarios when we have very IO-bound workload. We have work mem, which typically is the internal, like limits around this. But the fact of the matter is there's really no limit in most cases, because every process that kicks in, like let's say parallel workers or every user session or partitions that kicks in, it thinks that work mem is its limit, right? Like, so that means that if you had 3 or 4 of them, like all 4 of them would be actually, looking at the work mem. So in a simple configuration, this kind of works by setting the work mem, but you have to be aware of these other corner cases to currently make sense on how much actual consumption of memory is out there and what the limits of them are. Huge pages is yet another thing. There is on, off, and try, and the on, off is like what is obvious. Try is like it will try to allocate if there is huge pages available. If not, it will move on and try to do the regular allocation. The important thing to remember is that huge pages might be needed to be reserved in advance, and that will help you to make sure by the time Postgres comes up, it gets access to the huge pages by default. The next setting is something called overcommit setting. This is by default what Postgres documentation and is suggested. When you have a regular Linux machine, you don't have this setting on, and Postgres says, hey, set this up, kind of thing. But the thing to remember here is that in a typical Linux system, when you let's say you do a malloc, and then you try to write to the malloc, that is when actually the pages would get faulted in and allocated properly. And there is no limits to this. You can do like mallocs for a large amount until your virtual memory stuff, but you could have a case where your physical memory is still not used, and you will be fine. But when we use this overcommit setting, that is typically recommended in Postgres systems, if you do a malloc, and every time you do malloc, the memory gets reserved by the kernel. What that means is that Postgres can expect the behavior where when we are running out of memory, we will end up in a scenario where malloc would return us error rather than a fault, right? Like out of memory fault kind of scenario. So that is the kind of expectation of this, that there is a more graceful behavior. Somewhere, I think folks had the expectations that when a new user session connects and it's not able to allocate memory, it should be killed and stuff like that. But typically, if you run into this situation, then the entire thing goes bad. But the good part of this is that we won't have to actually do a lot of scenarios that we end up. We don't have to do recovery, right? Like that's where it will be a more graceful shutdown, because you get a proper error return from malloc. So that's the story behind the setting, but something to be careful around when you are dealing with many instances of Postgres in a cloud environment. if you're setting this, there are consequences of this, especially in low-end SKUs and things like that. So please be aware of this setting. Yep.
So basically how I always count, so when I have my maps connections and like map, so all this map, so in reality, it's hard to believe, but sometimes people actually use map sessions. So like my understanding was that if I here like do the map wrong and theoretically I allow to acquire more map than it has, so it will fail.
Yep,
right?
yep.
So it's like no magic here.
No magic, yeah.
It will fail.
Yep,
Right?
yep.
So I can, it can tell no more if there is actually memory is out there if
Yep.
I limit it like by parameters, but if I plan for too much, it will miserably fail, right?
Yep,
Okay.
yep, yep.
Just want to make sure.
Yeah, but workmem is tricky. That's the message I want to, I mean, typically when we configure it, we expect it to behave all fine, but there are scenarios where we are not calculating well. Max connections is not enough actually. But I would say a typical user, we don't have to worry about it, but as we get to sophisticated users of, let's say, we had a lot of parallel queries going on. Yeah, yeah. There you go. Yep, thank you. So a bit of back-end debugging sort of thing, like, like things which we could use to debug some of these things, right? Where actually our memory went kind of scenario, right? Like here is a couple of things we can use, which is, one is, as I was explaining earlier, the shared memory allocations, the PG mem allocations view. So I've put that on the right, like there you can see all the shared memory allocations, like it got snipped at the end, but like all the shared memory allocations that potentially could be happening in a process you can get using this. You will be able to understand like what statically and what dynamically these things will help you to get a sense of it. Backend memory context is the local memory context that is there. The thing to remember here is that we will be getting for that particular connection, like what's the backend thing. You can say that, hey, I want it for another process, let's say a worker thread that is running, you wanted to figure out what the memory consumption of that is. That also you can send, but it will be logged inside the system. So these two, combining these two, you should be able to figure out what's going on in the system in general, right? Because allocations are happening in these two areas. This still doesn't cover the kernel side of things, like you still need some more magic to make that happen, but this should be good for us to debug a lot of issues. Some tools and extensions like PG buffer cache is the extension I was demonstrating earlier, which can tell you what is the content of the buffer cache that is there. The PG prevarm is another tool which typically people use to preload the tables into the buffer pool as well. PMAP is another tool which you can use to actually map the entire process on the right here and then figure out what is allocated locally, what is allocated like in shared memory and things like that. So these are tools which, when you end up in situations where things are not going well, life-saving tools at the end of the day. Now that we have covered some of the fundamentals of all of this, let's talk a bit about some of the projects. Some of this are ideas which are floating around. Some of this have consensus. Some of them don't have. They are very contentious in the mailing list. So just wanted to lay out some topics around this. So there is a patch which is coming up in PG17, which we did as an intern project in our group, and Thomas helped guide this, and we are working on this, is to get to a place where we can invalidate the buffer cache. Like if if this tool can be it's part of the core Postgres, you don't need extension, but then you can call this invalidate buffer cache, and then you can get the buffer cache flushed or dealt with later. So this is not to be used in a user scenario kind of thing. This is more used in when you have to debug something, as well as this is a building block to some of the other things that we will talk about. So the next topic is like the memory shrink and expand scenario, where right now everything is kind of like static. If you have a buffer pool that is actually static, when you want it later, you still need to restart and throw away your context and build this thing all later. But the place where we could reach is that Postgres just stays on, and you can just expand or shrink this memory. And that's the idea behind this. So we could use it in a, let's say, serverless environment where we want to decrease the usage of memory as the more and more of these user interactions reduce, we can decrease the memory, and as the user comes in, we can increase the memory. So right now, Postgres doesn't have such things. It's all very static. So that's potentially one area that we could. Overbooking is another scenario which comes up when you have a multi-tenant scenario and you want to make sure that you can put two or three, not two or three, you can put multiple instances of Postgres into one, let's say, core node. And then you want to make sure that the memory, when one of these instances, we can free up and give it to another instance and things like that, which involves kernel at that point, which involves hypervisor at that point, and the whole stack. But this is another area where something like memory shrink expand could be useful. And anyone interested in this space, please let's talk. I'm very, very thrilled to talk about this, to get it to Postgres. Memory accounting and limiting. This is a bit of a tricky situation that we really don't have a good way to limit Postgres memory, right? In the sense that, let's say we want that to say this query should not be using beyond a certain memory, something like that. Some sophisticated limiting that we could use where we can manage the expectations of the users, or wait till some memory is available, right, where other users are using the instance and things like that. So right now, that facility is not there. There are patches in the mailing list where discussions are going on, especially on accounting and limiting, but they have not yet concluded, so we are still in the stages. SLRU was another topic which I touched upon earlier, where could we combine SLRU into buffer pool and have just one single way to manage the things which are disk backing in memory. There are scenarios where we have caches. When we execute a query, we end up with caches, but we don't free up that well on time. And that's another area we could do. There's a lot of performance improvements possible in allocation speeds. Every version gets it. PG17 has a bunch of palloc allocation speed improvements, memory allocation speed improvements that are coming up as well. And the other thing is like whether we could do more sophisticated buffer pool replacement algorithms. So those are the project's ideas which I want to spill out in the world and have folks look at it, and let's collaborate on this. I just want to thank, first of all, I want to thank all of you for coming to the session. It's been a long time since I've given a talk, so I've been, thank you for the participation. I want to thank our group inside Microsoft, which consists of both committers as well as contributors. So we have a group which focuses solely on making improvements in Postgres, adding features and improvements, not only on like specific areas, but we do things like CI/CD improvements. We do things like really AAO, DAO, and things like that. So there's a whole spectrum of things we do, and I get to have fun with my group here, and a lot of this has come from that. So thanks to them. Special thanks to Thomas Munro, David Rowley, and Anders Rowan, because they helped me gaining the knowledge and kind of like brainstorming on some of these aspects. Teresa from Microsoft helped me build the graphics around it, so thanks to all of them. Thank you, and that's about it from the session. Thank you.
So the double buffering, do we encounter the double buffering for the huge pages also?
Yes, I believe so. Yep.
Okay, thank you.
Because the page cache still has it, like when we take it from the thing. I believe so, but.
Yeah. Okay.
Yeah, so just a quick comment and then a quick question.
Yep.
The comment is, one thing I wanted to just kind of mention about enable CAsserts is that it also, when you do that, it also enables zeroing out each of your allocation sets, your memory contexts, when it clears them. So that that allows you to turn problems into crashes. But my question was, you mentioned huge pages. Have you seen any particular cases, any particular parameters where huge pages make a particularly big difference to performance, or is that something that's maybe outside of your area of work?
Yeah, I mean, we do recommend that in general. I have not like dealt with a specific workload which dealt with it, but in the past, I've read about workloads which, like out there, which benefits from this, but not directly dealing with it. Yeah. The older, like, databases, right? Like, I mean, the incumbents.
Okay, so Krishna Kumar, as he was getting up on the stage, told me that this is the first time in 18 years that you're giving a talk. And I told him that it is just like riding a bike. And I think that he proved that. It's just like riding a bike. So another round of applause for him, please.
Thank you. Thank you.
Thank you.
Thank you.